in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
Don't see the curvature of the earth. That stuff is black.
GLOBEBUSTERS taking over. Bye bye moonlight and rover. Now so mediocre. Sorry, but your ball is dead. But your ball is GLOBEBUSTERs taking over. Gotta ride this roller coaster, but the truth is getting closer. Sorry, but your ball is dead. But your ball is. Get the shovel for the space hubble, piecing up the puzzle. Need to burst your bubble, evil gonna crumble, yeah. Sit down, be humble. Got the ball, you better fumble. You get mad, cause I just fight about your uncle.
And then they call me the liar. I mean, it's absolutely unbelievable the pathetic techniques that they have to use to prove their heliocentric model.
Bob shot the president, Jeran got the evidence. Arrow slaying Jesuits and Zach Shark is evident. That the earth electric and its residential residence is heavens, and I hope to settle in like some sediment. If we so wrong, why they lying to discredit it? That's not too intelligent. That's a guy, not an in court, but we ain't really in the settlement. It's time to awaken from the pseudoscience sedatives.
GLOBEBUSTERs taking over. Bye bye moonlight and rover. Now so mediocre. Sorry, but your ball is dead. But your ball is GLOBEBUSTERs taking over. Gotta ride this roller coaster, but the truth is getting closer. Sorry, but your ball is dead. But your ball is.
Inner World Productions.
And welcome everybody to GLOBEBUSTERS. We're on to episode number 12.3. Season 12, episode number 3. It's all perspective. It is the 20th of October, 2024. And I have made a giant mistake that I'm having to correct right now. I put the GLOBEBUSTERS episode on the wrong Rockman account. So cleaning that up here real quick. It will be on the right one in a second, but let me put this up on the screen for now. We will say hello to our panel members. First, we got Zach, Good Times for All. What's up, Zachary Zabala?
Hey, Jeran. Doing pretty well, man. Doing pretty well.
You know, before the
I've
show,
been,
you asked me, Jeran, did you set up Rockfin? Next time you need to say, Jeran, did you set up Rockfin on the right account?
On the right account. Okay, I'll get that next time.
Write that in your notes, would you? Yeah, I'm having to switch it on. I accidentally put it under Jeranism's account. So anyway,
I remember when I did that.
Yeah, and then you called me
to your account. And I was thinking like I was live on your account somehow, like I had the power to do that or something.
Well, I got scared when you said that.
God.
I'm like, how would that happen? How would you possibly be able to go live on my account? But okay, we figured it out. So anyway,
so yeah, been doing good. You know, the weather's cooling off finally around here, and I got a lot of feedback at Flattoberfest about my books. You know, adults are just too nice. They are. Especially if I guess I'm a nice person, so people are nice to me. But children, they told me they don't like the art.
Really,
they don't like the AI art at all.
Straight up, this could be all right.
Yep. So I'm either because I can draw. I used to draw all the time when I was younger. I just am having trouble like getting my theme down of what I want it to be, and I've been thinking about it for a month. I went and bought some paper this weekend and some writing pencils and stuff, and I started, and I've crumbled up so many pieces of paper. So I don't know, maybe I'll hire somebody and get them. I don't know.
You should, yeah, put a call out to the community and see if anybody is interested in helping out that can draw and maybe been looking for a way to help.
Yeah, I mean, you know, it'd be a by pay thing. I couldn't pay you so much up front, but as books sell, you know, we could do a percentage or something like that. I don't know, but I definitely want to change the art because it was already irking me using AI in any part of it. But after I heard the children, and it wasn't just one child, it was 3 different children that were like, yeah, I like the writing and everything, but I just don't like the art, the pictures. And I was like, oh, okay.
Did you tell them get a life? That's what I said. Get a life, kids.
No, that's what I love about children. They're brutally honest.
That's true.
They just tell you exactly how it is.
Yes, that's true.
So
you notice that
I'm going to take their advice.
Moms never ask their daughters or sons, like, do I look fat in this? They just know better than that. I think I fixed this. I think I fixed this. Should be good. Everywhere should find the right link. Anyway, sorry about that. I sent you the wrong places. And then we've also got a special guest today. We've got Paul from Plain Reality. Paul, how's it going?
Really good, man. Thanks very much. Thanks for having me.
Very excited to have you. I've been wanting to do this for a while. And you've been on, StreamYard before, or not StreamYard, what do you call that? Speaker's Corner. So people definitely recognize you. And I guess start by just telling people who you are and why you entered this conversation and what you think you've begun to uncover while I fix some more things here.
Okay, well, on YouTube and Twitter, etc., or X, if you want to call it, my handle is Plain Reality. Pretty much I got into this possibly the same way that everyone else did. Actually, the very first thing that I saw that got me onto the journey in the first place was the documentary Health Matters. Don't know if you guys have ever seen that. And then that kind of got me started on how we have been lying and hiding cancer cures, etc., that type of thing. And then that just got me down the rabbit hole. From there, a few years later, obviously, some flat earth stuff started popping up. And I never watched any of it, but I was just looking and I was like, you know what, it wouldn't surprise me. Like, they're lying about everything else. So I didn't really come into it as I came in skeptical, of course, but I didn't come in with that, oh, that's ridiculous.
Right.
But I did ask a few trolly questions in some videos. Like I remember I asked someone one time, well, if I'm on the east coast of Australia, why can't I see the west coast of America? That typical kind of thing. And then someone just answered me. They're like, well, hey, dude, you can't obviously see through all the atmosphere. America would only be like absolutely tiny by the time you got there. There could be 40-foot waves in the way, rain, fog, all these things. And I just sort of went, oh, yeah, cool, fair enough. Good answer. I didn't have that visceral reaction of like, oh, that's ridiculous. Like, I don't get how people do that. I thought, well, that's a fair enough answer. I can't argue with that. Yeah. So then I got into that, and then actually when I had a P900 for a while, and I wasn't really doing much with it, and then I think it was Christmas. We ended up getting to a little bit of a discussion, and that kind of got a little bit weird. And so then I was like, well, I'm going to go down and start looking at things. And then I started on Twitter. I was having some conversations on there, obviously, and then we had trolls like Sly Sparkane and that just going hard. So then I went, right, well, I'm going to get out there and start looking at what's going on. And that's what sort of got me started into really getting out there.
Now, was it a friend that told you about Flat Earth or anything like that? Or did you see a video pop up or something and thought, hey, I'll click on it? Because I remember the first time I heard about it, it took me 4 months to click on my first video. I just thought it was the stupidest thing I'd ever heard of, and I wasn't going to waste 1 second looking into this.
Yeah, well, it probably took me probably somewhere around the same, just seeing the Flat Earth recommendation come up there, because that was back in 2015, 2014, 2015.
15, yeah.
Yeah, back when that was really sending you everything. And I just never really sort of clicked on it as well. I just sort of was looking at it on the side, and I was too busy looking into health and stuff like that at that time. I was deep into watching a lot of stuff by a gentleman named Dr. Robert Morse. If no one's heard of him, you should look him up. Personally, he's on the level of, say, a Dr. Sebi, as far as healing is concerned, if people would know who Dr. Sebi is. Mm-hmm. He's on that same type of level. So I was kind of more into that at that time. And then one day I was just like, screw it. So I clicked on it, and I'm not sure if it was a ODD 21 questions or maybe 200 proofs. And then I just went down from there. Went down the rabbit hole, I should say. Not down, but down the rabbit hole.
All right, well, awesome. And so you have a presentation for us today. I know we've got a couple other things we'll cover after. I wanted to talk a little bit about this chopstick catching rocket machine or whatever Elon Musk has built now. And then, I want to show some other stuff, few things. So, but first, let's get through a nice presentation from Paul here. And he and I had gone back and forth and talked, and I think he's definitely on to something that I've not heard anybody else really point out or just kind of understand. And I think it does say a lot. So let's have a listen. We'll all be interacting throughout. And if you guys have any comments, please leave them in the comments there, or in the chat, and I will put some of those on screen as we're going through. So whenever you want to begin, let's do so. Unless you got anything you want to talk about, Zach, real quick.
No, I'm excited. I love perspective and talking about this. This is going to take me back, I bet. It's been been a while since we talked perspective here.
Yeah, it's going to be good. All right. Just making sure we don't have anything in the chat that needs to be pointed out. Nope, we're good. All right. You are up whenever you want. There.
Okay,
Paul.
so we can see my screen now?
Yep, you're all good.
All right, cool. I just want to start by shout out to all the OGs, and if anyone doesn't know any of these channels, and I'm sure there's way more. I remember there's Observable Reality, and there's plenty others. But these guys are many of the OGs, and if anyone doesn't know them, just have a quick look there and get onto their channels, give them a sub, and start having a look, because they are absolutely fantastic.
Thousands of hours of observations.
So many. WideAwake is like one of the main reasons that I was able to see so clearly, because there were so many questions I had, and then just watching his stuff and watching him talk through it, learned so much. Same thing with the other guys as well. I mean, Sky Free, some of the best work, small scale reproductions of what we see in the atmosphere. Beautiful. BMLS 69, of course, everyone remembers him. Plain Truth 2.0. All great channels. Good.
Yeah, cool. So just to start off, here's a globe having a little bit of a spiral on one of my videos.
This video is responding to Reality's video here. He's got some sort of observation, which, mind you, he's on 500 of these bloody things in the same bloody location and never moves away. If it goes anywhere else, I think. Anyway, he's 5.
Okay, so I just find it quite laughable that someone would make a comment of like, oh, this guy's done 500 observations from this location, and as if that's like a bad thing. Like, isn't that meant to be kind of how you do? I mean, I know I'm not doing science, but aren't you meant to go out and repeatedly do something to see what's actually happening within what you're doing?
Well, yeah, I could see them being snarky like that if they went out and did one observation or 2 observations. You could say something like that. But when you go out and do 500 observations from the same spot, you're going to have a good, pool to pull your data from. That's how you do it.
Yeah, exactly.
Yeah,
and what I've started doing now, because I have had some people comment on this. Obviously, trolls are going to figure out any way that they can try and get around you. And they're like, well, you're showing something from low tide and something else from sort of more of a higher tide. So now what I'm actually been doing for the past almost 2 weeks now is I've been going out right on low tide and then right on high tide. And I've been getting both from each day. So except I've missed a few days because I've been pretty busy, sort of finishing up this presentation and busy doing a few other things. So I've been getting it at least once a day at the moment. But in general, I'm going to start doing high tide and low tide. So then, I can have the complete comparison and no one can complain about anything.
Well, let me give an example too of why it's so important to do multiple observations and with multiple equipment, because remember when we went down to look at the islands down near LA, that we had gone on that one particular day and didn't see it the first day. The second day we all went out again and nobody that was there saw the island. And it wasn't until we looked through my camera, the infrared camera, that we saw that the island was there. So that's just to show you that if Globers went out on the one day that they wanted to go out and they went and they said, let's go see if we see this island, and they go and they don't see the island because they would say, oops, blocked by the curvature of the earth, they would go home and say that they proclaimed globe evidence and globe proof, when in actuality, the island is there. It's just you have to look through an infrared camera. And of course, infrared cameras don't see around curves. So what you're actually seeing through is more atmosphere, which tells you all you need to know about what you're actually seeing when you're looking at the horizon. But multiple days, if we would have gone out there multiple days, multiple equipment, different cameras, that's your best bet. Go ahead.
Yeah, exactly. And do you know whether people do see that island from there in general? Like not in general, but are there days when the people do see it, or is it always hidden?
I don't think they would ever look for it because you have to look through. I mean, you have to see it through the infrared because it's 70. Yeah. It was 70 miles away from where we were.
Yeah, that's a lot of atmosphere.
Yeah, that's a lot of atmosphere. And again, you're looking right above the ocean too. So I mean, that's your muckiest, worst part of the air. But one thing I just want to mention too, just I always wondered, is it's kind of like if you think about looking out over the ocean, where's the most mucky air? It would be right at the surface, right? And then it would go less mucky as you go up. But it's just funny because I mean that alone answers, if people were to answer, well, why do things disappear from the bottom up? You would say, well, that's what you would lose first because it's behind the most atmosphere. But it's just funny that they act like it's impossible, that there's no mechanism for things disappearing bottom first. Okay, then.
Isn't that classic? There's no mechanism.
No mechanism.
How on earth could that even happen? It's like, do you even have any kind of imagination?
They do not. And this is another thing I've noticed recently, that I've noticed now that Globers cannot answer questions that they have not been given the answer to. What I mean by that is, like, there's one guy in my Telegram chat that goes off on, he's just going off about globe facts all the time. The other day, I just interrupted him just to ask him a question about, I was having like some issues with Indians, the Native Americans in the United States, just wondering, it just hit me like, wait a second, how would they be given land and sovereign status and basically told you don't have to go by our laws when we were clearly defeating them and destroying them in a war that would have just wiped them out? So I was like thinking, like, that doesn't make any sense. Like, why would the United States give somebody land in their states and tell them they don't have to go abide by the law? So then it hit me. I think that those Indians probably turned in the other ones and they were working with the guy. Anyway, besides the point, I just asked him that question, and you should see these guys. They break down. They can't even fathom a world outside of what's in the physics book. Like, they're just like break down. They can't talk about it. They can only talk about things that they've been given answers to. Where I find somebody impressive, where I give them a situation like that, where, hey, help me explain, how do we have Indians that live in, these reservations where they've been given casinos, told that they don't have to abide by our laws, and then there's like just a small amount of them left. It just doesn't make sense. Like, you wouldn't just destroy. When have we ever gone to war, destroyed a whole country, and when we get to the last group of them, said, here you go, have this free land and live there without laws? It just doesn't make any sense.
Yeah, no, it doesn't really make any sense, does it?
Anyway.
It's kind of like they don't really know what to, like, we get told that they learn to critical think in university and college or whatever, but
right.
It's like as if they get taught to critically think within a certain frame, and then they can't go out of that frame.
Well, isn't it a sign of intellect to be able to, just think about something a different way? Not believe it, but to actually critically think about, okay, well, maybe if this happened or that, that's a sign of intelligence.
Yes,
not to just, well, that's not what I know and that's not what I was taught, so I can't even fathom that idea.
One of the things that comes up with that one is the spin of the Earth, right? Because any glober will always immediately correct you when you try and say that there's a speed spin, right? They don't want, that's like not allowed to be talked about. No, we don't talk about the speed. We talk about rotations per day. Of course they want that, because they can then just say the Earth rotates 1. Now, by that same mechanism, then you would say, well, what is a merry-go-round or a carousel, right? So is it faster or slower than the Earth? And you're like, well, it clearly goes around, about 3 times a minute? So that's it goes around 180 times an hour. So that times 24, 180 times 24. So that goes around 24 equals 4,320. So it's 4,320 rotations per day versus the Earth is 1. So clearly the carousel is 4,320 times faster. But that's not the case, because we also can say, well, then if that carousel is going around and it's only 100 feet in the circle of the circumference, then it's going around 300 feet per minute. And then we multiply that by 300 feet per minute times 60 minutes equals 18,000 feet per hour. So then we're going to divide that by 5280 and get our miles per hour. So it's 3.4 miles per hour. So a carousel is going 3.4 miles per hour and the Earth is going 1,000. So it's a little bit more of a, if we go by rotations per day, then you're right. We can make up any kind of nonsense that we want and make people believe it. Oh, the Earth only goes once a day and the carousel goes around 4,320 times a day. But that's not what's important. Edge velocity is important. If an ant was sitting on the inside hand of a second hand on a analog clock, and they're sitting on the very inside towards the center, they'd be moving very slow, versus an ant that crawled all the way out to the outer edge would now be flying a lot faster on that second hand. Same thing is true on the Earth, and we just happen to all be living where? On the extremities of the so-called ball Earth. So therefore, we would all be experiencing this crazy speed. And I've shown people before what it looks like to be going 1,000 miles per hour. To think that the oceans just stay still, lakes stay still, is insane. But just to bring up that example, they won't even go into that conversation if you want to talk miles per hour. They break down because they've been told that we don't discuss miles per hour, but they don't know why you don't discuss it. They say, it's not how we measure rotational speed. Well, why not? Why not? Why don't we measure rotation? Why can't we talk about it? You may not measure it that way, but we can talk about it. It is distance over time. The Earth has to travel 24,901 miles in 24 hours. Distance over time equals your speed. It's 1,000 miles per hour. Get over it.
And I'm sorry, but we didn't make up the numbers. Right. I mean, I was taught that they change at different latitudes and all that kind of stuff. So, yes, it is. I mean, in miles per hour and kilometers per hour, however you want to look at it, and that's how we were taught this.
Right. Otherwise, the
that
person
they don't
at
want to bring it up is very telling to me.
Right. The person at the equator would be going the same speed as somebody at the North Pole, which they don't believe. So it's like they've been coached along the way of exactly how to give the answers that keep the lie going. Anyway, sorry to interrupt you. Go ahead, Paul.
No, that's all right. Yeah, I probably should continue on. So, the horizon, how does it work? And this is what we're going to be going over. And so part one of this, so it's in 3 parts. Part one, we're just going to go over perspective and the horizon. So it's just a basic little lesson on it. But let's just go over, I found a couple of explanations of what the horizon is. So the horizon is the line we see where the sky appears to meet the earth or sea. That's the general one that most people would know, where the sky meets the earth or ground, where the sky meets the ground. It is the visual boundary that delimits our field of vision. Now, the next one I found very interesting. When we gaze at the horizon, we witness the sky and the earth coming together in a straight line that extends to infinity. Well, how does it extend to infinity? I thought shouldn't that be where it curves? I found that kind of interesting. So, and this comes from Worksheets Planet. The next one, it serves as a symbol of the vastness of the world around us, inviting exploration beyond what meets the eye. So they're very descriptive, these guys. And the next one, the horizon provides a sense of perspective, reminding us of the immensity and diversity of the environment that surrounds us. So yeah, I just thought that was kind of interesting. And then just one more. And this was obviously from a art site, or from something to do with art, where they're talking about the horizon here, where it says this is the horizon line or eye level. And we all know that when you actually take a measuring device out, it's not perfectly at your eye level. But, you know, I mean, I ask people all the time, I sort of, while I'm out there on the jetty, I go, when you're looking out at the horizon over there, does that look like you have to look down to it, up to it, or are you just looking straight across? Well, clearly, I mean, I'm only 20 feet up, and obviously everyone says, well, no, I'm just looking straight across. I'm like, yeah, kind of like at approximately about your eye level. And they're like, yeah, approximately around there. Yeah, I'm like, yeah, amazing, hey. But so we go into it here. It doesn't matter if you are peering up or down, the horizon line remains the same. It is flat like still water and is at your eye level. If you move your body up and down the horizon line, your eye level moves up and down. So there's a nice one there for Ruhif, who came in one day to Discord and said, if you, because some of the things that I show, the camera angle is down, and he tried to use that as an excuse. He's like, well, the camera angle is pointing down. Well, clearly here they say if you move up or down, or you move your eye line in any way, the horizon stays the same. So yeah, sorry, go on, what were you going to say?
No, I wanted to point out, because I think it's funny that recently I was looking at exactly, I could tell that a lot of the words that you were saying at the beginning there came from the original Wikipedia, because it's almost word for word it. But now if you go to Wikipedia, I just want to show people this. This is what Wikipedia says today. It says, the horizon is the apparent curve. Excuse me? The horizon is the apparent curve that separates the surface of a celestial body from its sky when viewed from the perspective of an object. Now, if we just go to the Wayback Machine and go to any date.
Is it back up?
Is what?
The Wayback Machine. I heard it was hacked.
That's what I heard too, but it's up. I just tried it right now. So you can go to
cool.
any date in the past, and you'll notice that it says the horizon or skyline is the apparent line that separates Earth from. So this is what is changing history, changing science. They've been doing this the whole time we've been doing it for 9-10 years. And you guys know that if you watch the show, that we have been causers of change, but it's not a good thing, because what they're actually doing is correcting their places that they need to. And eventually people are going to be, what are you talking about? The horizon's never been described as a line. It's never been said to be straight. It's a curve, right? Because that's what it says in current Wikipedia. So just funny that they're able to go in, and this is what Wikipedia is great at, right? It's like a never ending, able to be updated live definition machine, which is like, wait.
That could be a show right there.
It could be.
Jeran,
really could.
If we went back and all the stuff they've changed.
Oh, man.
Especially back in the day when you were just putting out videos like every single day.
That would be awesome.
And it seemed like every other week they were changing something.
If we took like the top 20, 30 topics in Flat Earth, found the Wikipedia today, and then found it from 2000, excuse me, I was eating a strawberry. Since 2014, we'd be shocked.
Yeah. Oh, yeah.
But they do it so little in little ports that nobody ever notices. It just takes a big one like me showing up to this and saying, let me show you that it says straight line. Then you come here, there's a apparent curve. It's like, what? But anyway, go ahead. You're back, Paul.
Okay. All right. So we move on to the next one. So when we're looking at this horizon, how far above the railing do we think the camera is? All right. So kind of, could anyone have a guess? Like, I mean, we can see that the horizon line is cutting right across sort of the middle of their backs.
Yeah, I'd say not high then.
You know, so if we say that these people are, you know, let's say they're 6 foot tall, drop 1.5 feet from that, you know, and we've got the camera is approximately about 1.5 feet above the railing. So when we're looking here, and we've got a couple of little boats over there to the right, doing what perspective does. One's in front, one's behind. So we can tell by, you know, one's closer to the horizon, being that it's higher in perspective to the horizon. And now I drop the camera down below the railing, and what do you know? There you go. We're looking straight through, and we can see the horizon. It's not above the railing now. It's now below the railing where the camera is. So clearly the horizon is moving up and down with us. Absolutely. Now this is from Heath, just recently has been doing some great videos. He's done this, I'm thinking this is his program, where he's sort of made this entire program up. And he says here, now we have the lowest path, which is that lowest light path there, which is tangent to the surface and therefore gives us our apparent horizon. So I would say that we're predominantly getting upward refraction where the light is bending up. And that point where the light bends, the furthest point where that light bends, that is what creates our horizon. Because from there it starts going up and we can no longer see the surface because that part of the surface of the light isn't getting to us. And that changes all the time. So the horizon is the furthest part of the surface that can be observed. Is the point of deviation where the light rays closest to the surface begin to refract upwards. So this is kind of like how we would see it in a view that no one ever actually sees, side on. And so here I just want to introduce a little character here, Surfy. What a great person on Twitter she is. So I've got a few little things here. So she's our resident female globe troll. Now, this is how we actually see. We see in perspective. We see everything ramping up to the horizon. And from the horizon, we see everything ramping back down. We're going to be going sort of deeper into this. Now, I've got her saying she has no idea what a mirage is because we had this little thing one day where she posted one of Soundly's things to me. And I'm like, oh, well, why are you posting something that's in an inferior mirage? And she's like, you don't see an inferior mirage in the video I showed. And so I'm like, well, clearly you have no idea how to look for one in the first place. Because there is, I mean, it took me half a second to realize that was an infrared mirage.
Yeah, then, just about every long distance observation like that, unless you have the sun, you know, backlighting it, this almost always occurs. Almost always. Every time I've been out to Lake Michigan and I'm looking, you know, 35 plus miles over to Chicago, I got this. Where you can see a distinct line and it mirrors everything above it. It will be below it, just inverted. Yeah, this always happens.
For sure. An infrared mirage to me is the most common thing you get. I actually had someone one day, like early on, I'd probably only been doing observations for about 4 or 5 months at that stage. And that person said, oh, infrared mirages are rare. And I'm like, well, you've clearly never gone out and looked because that is what I get. Probably 60% of the time.
Mm-hmm. Yeah, especially early morning, late afternoon when the sun's kind of low.
Yeah.
This is always happening to me.
Yeah, definitely. Now, Sly came in and did a bit of white knighting, and he sort of did that little thing there, if you look where he says, oh, he claims that 28 stories are blocked by this little mirage. Check out my analysis skills. Well, if we look at this, we see that this is an infrared mirage going on right here. And then we can see how it generally looks on most other days. So that's what I'm actually seeing most of the time. So when I say that yeah, I do think an inferior mirage can hide all of 28 stories quite comfortably over 26 miles. It certainly can. This is those little houses there are 16 miles away. They start at 115 feet above sea level. And in the image on the left, they're blocked by, not quite halfway. So let's just say there's about 125 feet missing. So over 16 miles, we have a inferior mirage blocking 125 feet. Now, the only reason I use this image rather than another one I have, because I do have an inferior mirage that you can't even see these houses. They're gone. They're not there at all. So, we can get 140 feet blocked at just 16 miles away by an inferior mirage.
And I could get this to happen on the floor of a warehouse I used to work in. Not very far. It's less, and I even got it at one that was like only maybe 200 feet I was using. But you get the same mirage happening at very short distances.
Yeah, over land, yeah, they happen pretty quickly. They don't take far for mirages to happen over land. But then, who was that guy? They did that 7-hour or 8-hour video. He used an example of an inferior mirage on a road.
Veritas?
And I tried to say, well, it's not really a great example because over the road, you tend to sort of get it really sparse and sporadic. Whereas over water, it's like once the inferior mirage starts, it's like, bam, it just goes on from there. But on the road, it can kind of start and stop. So it doesn't really give you the same
almost like
effect.
it's breathing almost.
Yeah, it's not quite the same as what it is over water. Over water, it's definitely different. But so here now, what I'm going to be doing is going into the actual horizon itself, and I understand that the horizon is where the sky meets the ground. The ground is actually the mountains. The ground is not the water. Here, when we have water overlapping or going into the to the land here, but this is also referred to as the horizon. So I've had people say to me that that's not the horizon, but it clearly is. So just about 10 seconds of this one.
But sure enough, as the boat reaches the horizon, the stripes begin to disappear one by one.
So clearly we have Nat Geo calling this the horizon, even though we all know that obviously that wasn't the horizon. Because
that's so bad with the horizon right behind it.
So it's just ridiculous. And that could be miles. I mean, if this thing's already 2 to 3 miles away, look at the height above.
Yeah, it could be it could be seriously 15 miles.
Oh, yeah, quite casually. Anywhere from 5 to 15 miles, no drama at all.
Mm.
Okay, so we can see that that's where it actually is. And here we have this image on another day. And so I will be referring to this as the horizon sometimes. So when I do, I don't want to have any globers spiraling. And if any globers are going to spiral out there, I've included Nat Geo's contact details. So you can always just contact Nat Geo at nobodygivesadobe@karen.com.
Okay, cool.
Yeah, so if anyone wants to contact them, by all means, go ahead. So when we're looking at this and we see this and we can ask ourselves, how far away is this horizon? We can see it's a nice clear horizon, it's defined, and what can we tell about it? Like, we don't really know anything. We need to know a couple of things, right? So obviously, first thing, we're going to be wondering what's the observer height. The observer height here is 28 feet. So then we're going to go on to a curve calculator. It's the easiest way to do it. That's going to tell us that our geometric horizon is 6.48 miles. So would that be right for this occasion? Well, no, it wouldn't be. We get a little bit more information, and now we see that there's an inferior mirage. And an inferior mirage, 100% of the time, brings the horizon closer to you. And from what I've seen so far, it'll bring it anywhere up to 2 times closer than what the geometric horizon says. So this horizon could be only 3 miles away. So now we have a few questions to ask. How do objects in the foreground appear visually in relation to the horizon? And I say visually because we all know that they're all on the same level. The boats at the front are not actually lower So the boats closest to us are not actually lower than the boats further away. They're all on the same level. But this is how perspective works. How do objects appear visually on the horizon? As we can see, when something is on the horizon, it is in the visually highest perspective position we can see as far as the horizon is concerned. And then how do objects appear visually beyond the horizon? Oh, yeah, sorry, I forgot. We've got our local Globe Earth hero here, Super Sly, our
peace be
Globe
upon
Earth
him.
troll.
Yeah.
I wonder if that's Sly Sparkane from back in the day.
Yeah, maybe. He's our little Globe Earth hero, and we're wondering like how is this Globe Earth confirmed? Come on, buddy, let's just check this out. So where's the bottom of the ship? Oh well, we're going to go over that, mate. Can it only happen on a ball? I don't think so, man. Don't worry, we're going to explain all of this. Yeah. You're dancing now, buddy, but your ball's about to crumble, and your words are about to go up in flames. And let's get out of here, man. Let's get back to the presentation.
So
all right,
we know.
Sorry. Let me just go here. So we've got a little thing here from Phuket Word now, and I sort of do a slight little interject here. He's just going to give us a general description of what we've just been going over.
So what we know about perspective, and can be proven every single time, is that anything that is above your eye level will appear to sink down towards eye level as it goes off into the distance. Yeah?
So I'm just going to reiterate the point here. As he just said, everything that is from high, that is above our eye level, will drop in our vision. And he didn't say it at this point, but he said it many times before, and I think he says that later in this video. But everything that is below us appears to rise visually. Now, if he had have actually had a longer table, we would have also had a horizon made by this table.
So this one's very big now because it's very close, and this one's far away, so it seems smaller, and that one's even further away, so it seems even shorter.
Right, so I love the way that he sort of seems like he's explaining that to a child, because sometimes it feels like we do have to explain things.
Have you ever seen that one comedy? It's Father Brown or something like that. It was a British comedy, and he's explaining how the cow in his hand is not bigger than the cow out in the field, the little toy cow. Yeah.
This one's big. This one's small. Far away. That's the one, isn't it?
Yeah.
Yeah. So while I was watching some of Phuket Words, actually it's quite funny. I was sometimes I just sort of put things on while I go to sleep, and I woke up and there was one of the videos that was on was a Phuket Word one, and I ended up watching that one, and he recommended to go watch this video here. And then on this video is a call where you were on this one, Zach, from Vortex Pup here, the Great Switcheroo. And this was a excellent conversation. So if anyone hasn't seen this, I highly recommend you go watch this.
Yeah, that was huge. I wish we could have put out part 2, because that's where he got into the angles and stuff a lot more. But this, whatever software he has, he's an engineer, Gav, the guy in the bottom, and he has this software where he can just take a picture and it points out all this stuff for him, and he can measure it, the angles, and it gives him all the angle measurements and everything. Really neat software, but it was really expensive. It was over like $2,000. That's why as soon as he told me the price, I was like, okay, I'm not going to play with that one then.
No, fair enough. Yeah, excellent video. The stuff that he did with showing the eye and reducing the angle in the eye and everything, it was incredible. Great video. But yeah, so he had this and then shows this here, and as we can see, everything from below, everything closer to us appears to be lower, moving higher as it goes visually, and everything that's in the very highest part, the yellow at the top, going down. Now here's the jetty that I stand on, Grange Jetty, clearly doing all the exact same things. We can see everything that's closest to us looks very low, everything getting further away seems to climb and get higher in our vision. And obviously we know that it's not actually getting higher. It just appears that way. Now, I actually had someone, when I did some of my observations and put it out on Twitter, and someone went into, can't remember who it was, but some globe troll went into Twitter went into Google Earth and put a little drop pin on the jetty. And for some reason, when you put a drop pin on jetties, they generally say either 0 or 1 meter. So then he started going, "Oh, you're only 1 meter above the ocean there. You're not 5.5 or 6 meters." And I'm like, dude, you're trying to tell me that there's a jetty. Can you point out a jetty anywhere on Earth that's over the actual ocean that is 1 meter above the ocean? I'm like, are you kidding me? And he wouldn't drop it. Like, he just wouldn't drop. I even showed him this. He's like, "Oh, that could be 1 meter." I'm like, oh my God. Like, this is the level we're dealing with. But yeah, anyway, so here we have a old, probably World War II picture. Wow. And as we can see, everything that is high is dropping down towards converging with the ground, and everything that is low there is back one. Everything, so I've just taken the boats out, and we can see all the little lines there as they are progressively getting higher and higher towards the horizon. Now, we can literally tell with these objects which ones are closer and which ones are further away, right? Just by how high they are in our vision compared to the horizon. Now, also, imagine if we were now on the jetty. This would look the opposite. All of those ones furthest away would be the ones that are lower in our vision. And I mean, these people may even be a little bit too far away for that, because these people are probably now 6 miles away from where that jetty is. So they may be too small for them to see, but this would actually flip. The whole image would look the opposite way around. My computer skills aren't good enough to do some kind of flipping of that, so we can all just imagine that. Now, I'm just going to go over multiple examples here, and we can see, obviously, that there is never an example where this doesn't happen, right? So I put that little red line there because we can see how far below the horizon visually this boat is. This is what we need to keep in mind for later on, right? So when we're actually looking at the horizon, everything, as we can see, that boat there on the right, the one that's further away, see how the horizon cuts halfway in it? So this is where I'm going to go into later with evidence that if we were on the other side of this horizon at the same distance that I am from this horizon, but they were on the other side and all conditions being equal, that boat we're looking at is more than likely that distance below the horizon for that other person. This is what I'm looking at.
Repeat that again for people. I want them to recognize how eye-opening and how kind of revealing that statement is, if they really think about it. Just one more time. I don't know if people really would have caught the importance there.
Yeah, we're definitely going to go well deep into that. But yeah, so
no, as long as you'll cover it further, that's great.
Oh yeah, we're definitely going to cover it. And this is the whole third section is all about that. But as you can see, this boat is below the horizon right now. So we can see this. We can see the horizon there, and visually in our vision, because it's all just our vision. It's all just perspective. This isn't really below the horizon. We know that it's not below the horizon. We know that it's equal. It's on the same level plane as the horizon. It is not below the horizon. But visually, we see it below the horizon. Now, if we're on the other side of this horizon, that would be visually below the horizon. We wouldn't see the bottom of this boat. But we'll continue on. And we see this with everything. So we see this little, I'm not too sure what to call this little thing on the left-hand side there, but I found out recently apparently that supplies water to an area called West Lakes. And we see the other boat there, kind of hidden by the horizon. We see my little buoy there, well, one of the buoys. They're all pretty much on approximately the same distance away. And we see that boat completely below the horizon there. Even when we're getting funky things happening, it doesn't really change anything. You see the horizon, the boat still below the horizon there. I'm just going to sort of flick through quite a few examples here. Got the buoy there. even when we get compression of everything. So we can see how compressed all this land is now. We're actually still seeing the entire piece of land there. All the way to the bottom, we can see on the right-hand side, I should have probably marked it out, but there's like a little roof at a marina. I can see the little roof there. But we can see that all these boats are still, even when we're getting compression, it doesn't matter. Nothing changes. Okay, so I don't like to say that this couldn't be falsified. It just never will, because every single observation you could ever do, everyone could, right now, if you've got a hallway in your home, if you're looking in, if you just got a table in front of you, if you look at that table, everything that is closest to you on that table will appear visually slightly lower than the things further away on the table. It just happens with everything. There is nothing in this world that does not behave in this perspective way. So I'm just going to kind of keep flicking through these. So we can literally tell which of these objects is closer and further by just drawing these lines. Right? So we can see that where the buoy is, and we can see the horizon like well beyond. And I get that there's a lot of distortion here, but I'm going to show a clear video where it's a very clear day, and you can, like, I can almost see the rocks on the very far shore. Like, it's that clear. Okay, and to the right there, I'll go over that later, but that's where I've done some mirror tests from to the right there, and had the mirror down to the sand. So here I included a little one where, so we can see here, see how the land is sort of as if it's starting to lift there? Well, see this picture on the left? That is that piece of land.
Wow.
So when people sit there and say that these things are being lifted up over the curve, that's just complete bull. Like I'll keep it PG. When we see the land or anything being lifted, we're talking superior mirages. We're talking fata morganas. Like, we're not just talking normal vision. Everything doesn't look normal when we see it being lifted. Now, this is an extreme case where that whole bottom section has compressed all the land up. So it's almost like as if you can see where the darker part of the water is at the very base. It's almost like as if that part there is the water section at the base of that land, and we get this separation of the water. Excuse me for a second.
Mm-hmm.
We get a separation of the water here, and everything kind of like lifts, and as it lifts, we sort of, the water is, it's like it stretches up. I don't really know how else to explain it. It's a mirage, right? It mirages and it stretches everything up. And as it stretches everything up, it compresses everything. So that's the actual entire land there, just compressed. So sorry, I've got plenty of examples of this because I want people to actually see that there is no time when this doesn't happen. So you can see here how that we've got the stretching of the land there. If you were to just take that bit of land and drop it back down to the ocean, all that bit in the middle would be gone, and that would be sort of how it is now.
Mister,
I like to look at this as like a surreal painting. It gets that, is that the right the painting style, surreal, where it kind of has that real blurry look? Because this isn't me being blurry. This is the actual what the camera's seeing. And although I do fully admit that quite often I have completely screwed up because I don't always use glasses. I'm getting older, and my cameras sometimes have been out of focus. I'm trying to improve on that.
Yeah, that's easy to do.
Yeah, it's really annoying. So we see here again, and I'm going to go over some of these. Now, actually, this is pretty cool. I got this where these boats literally look like they were floating on a cloud. And
wow.
They are behaving all the general rules of perspective as they do. And if we were to just add some water in here, we now have floating boats. So what we had there was really smooth water. The water was like glass. And I don't know if we explain it as it's reflecting the color of the sky, because it's not miraging. So it's not that kind of reflection, because otherwise then we would have miraging on the boats.
No, I think that gets more into, well, no, because the boats are there. Yeah, I'm not sure. I know diffraction does that. It mirrors what's above it, below your line of sight.
So,
but I'm not sure when you have, like, the boats look so clear.
So what I've heard, and this, I don't know if this is true, but they say that this happens when the water is still in the back and choppy at the front. And then it just mirrors the sky, the water, because it's so flat, and that's what's happening. Because, I mean, again, it can't be anything to do with, like, you know, it's certainly not a, what do they call that? The Fata Morgana.
Yeah, definitely not.
They love to say it's some sort of super looming or anything. It's not that either.
Yep. No, I completely agree with that, because what we generally get is, like, this water here is smooth. It's like glass. But if there was a little choppy section of water there, then that would create a horizon. And the plain truth Travis, he would tend to call that an ether band, where it sort of cuts across there. And you can get those little ether band things. They can run for miles. Like, you know, we can get different colors of water, and that color of water, one color will just run for miles all the way across the horizon. And then you see like another color run all the way across the horizon, or before the horizon. So maybe I'll just sort of skip through these a little bit quicker here. But as we can see, there is never
We've got time too. You're not rushed into anything. So
yeah, cool. No worries. This always happens. So we can see the boat in the background there. It's got a little, it's starting to get that stretching effect, little Fata Morgana going on there. Now, here we have a rock wall that's to the north of me. Now, this rock wall sometimes is on the horizon. I'm not too sure if I put it here now. It's these next group of pictures. Yeah, right. So here we have it. So here we have the horizon well beyond it. Now we can see the land going all the way across here, and then we can still just see above that black line a little bit of land just there. Well, that land is at most 8 meters tall, and it's 20 miles away, and I'm 20 foot up. So it should be, you know, well over 100 feet.
Wow.
Unseen. And that can happen quite regularly. So what's not happening is it's not being lifted. We're getting the horizon extending. We're just able to see further. So how we're going over, like with upward refraction, it's the light bending upwards. All we're getting is the light being able to travel straighter, further. And right at the point where the horizon is created is where it's now bending. That's what I would put up. And thanks to Brian from Flat Earth Tests, he just recently did a debate on the horizon, and I'd been looking for a bunch of these lasers bending up because I'd seen them before, and he included that in there, so I pinched that, and I'll show that a little bit later. But okay, so here now we have, this is in an inferior mirage, it's the same thing, but now that it's on the horizon, it's the furthest, it's the highest point that we can see, it's the furthest part of the surface that we can see, so now it's at the very top of our vision. Right, and we have the little guy on the boat there below it. Have another picture of it there. And now we see the horizon slightly behind it. So now it is not on the horizon, it's in front of the horizon. So now it is slightly lower than the horizon, because everything behaves this way. When something is on the horizon, it is in the highest visual position. Clearly we know it's not actually higher. It's all visual. It's all optical. So there it is on the horizon again. Here we have another one where it is not on the horizon. We see the horizon well beyond it. And I don't know if you guys have ever experienced this, but I've seen many things where, you know, maybe some land or a boat is appearing halfway below the horizon, and you get a whole bunch of comments underneath there going, oh my God, someone should call the Coast Guard. That boat's clearly sinking. It's below the water, et cetera, et cetera. Well, I think that someone should have called the Coast Guard or something, because there must be a tidal wave coming in here. And all these people are about to drown. Right? But that's not what's happening. We just have the horizon has been extended. So the horizon is now further away from us, and everything then obeys. It should be a law. I don't know why it's not a law, because it's never not doing this.
law of perspective. See, they don't really get into perspective so much in science. It's more considered art. It's the only place they really teach perspective anymore. It's weird. Like, I never learned about perspective in science class or any of that stuff. It was always an art class where I learned about, the vanishing point and things like that.
Yeah, it seems to be the only conversation of where it actually is.
Hello, guys.
Ew.
How you doing?
¿Cómo
Excellent.
estás?
How are you?
Nice. Yeah, I have a live stream my channel talking about the, I don't know in English, I think it's extraocular vision, or when you can see without the eyes and you can see in with no, I'm going to search the correct term, but it's a practice. It's a practice when you put like an antifaz, something to block your eyes, and you see through that object and see.
Oh, yeah. You can do that with a cardboard tube.
Yes, exactly. And I experienced that last week, and it's something that blew my mind. And I give a live stream, talking about my experience. But keep going, please. I heard about the perspective, and let me just emphasize that not only in the art class you talk about perspective, but you just talk about the geometrical perspective and not the optical implications of the atmospheric phenomena.
Mm-hmm. Absolutely.
Would change everything, If you combine both, it's a completely different world view or view world.
Yeah, the thing you're talking about, is that the one where like all of your vision seems to go into it, just like a tunnel? Is that what you mean?
Well, not. I have my camera here. I don't know if you can see. Can you see my face now? I don't know if I'm sharing my face.
Yeah. Do you want us to share the screen?
No,
Okay.
I just want to share my face right now.
You look really good. You sure you don't want everyone to see how good you look?
Okay, but
For a minute,
the
just for a
people are looking at me.
No, they can't see you because it's still sharing screen.
Okay. Well, you put this. You put this like this.
Okay. So he's got like
And
a
you are-
eye mask or something.
Exactly. And you are completely blinded, but you start, making stuff because I cannot explain correctly because I have a teacher that gave me this ability or these teachings, and the things start to disappear and you can see through this as if you don't have anything in your eyes. So it's completely crazy, but it's real. I mean, I don't know how to I can share screen, but I don't want to deviate the topic that you are talking. Maybe later I can share my experience.
Yeah, awesome. We'll do that after the presentation. Oops, what did I do here? Screwed that up. Okay, go ahead, Paul.
Yeah, cool. So now we're looking at the jetty here. We can see that there's like a little reef area there. Now, in between that reef and the jetty is actually talking 3.5 miles. So the reef is 5.5 miles away. The jetty itself is 8 miles away. The buoy is 3.6 miles away. So in this instance here, what we have is between the first two lines, we have 2 miles, and then between those last two lines, we have 3.5 miles. And we're seeing all the way across this day. I can tell that because I know how the sand and everything looks there on the far edge, and that's more like 9 miles away where the sand is. Now here we have another one. We can see that little jet ski on the left-hand side there. I've drawn that line all the way across, and we can see what the buoy is. I drew that one in red, so we can tell that that boat is just slightly closer to me than what the buoy is. And now when we redraw it, we can see that as it's moved, it's now slightly beyond that buoy. So just by actually, when you get a photo of something, by literally drawing the lines on there, we can tell how far away, well, maybe not how far away exactly, but we can tell which ones are closer and which ones are further away. Once again, we're just clicking through here. This never changes. It never will change. We have the buoy on the horizon there again. We see the boats below the horizon. Okay, this is going to end soon, so we'll be on to part 2 shortly. But there we have a boat just sort of being stretched up. That is going into a bit of a Fata Morgana. Okay, I'll just sort of skip through here. So this is an area called Hallett Cove. You will see some other...
Man, thank you for putting in all the work. This is awesome.
Yeah, no worries, man. It's my pleasure. I actually quite enjoyed going out there and doing it. Okay, so now we get into part 2. The horizon rises with the observer. Now, I'm saying the horizon rises with the observer because that can't really be denied when you actually look into it. If we say that it rises to eye level, well, they're going to deny that because we can pull out a device and that device will show us that it isn't perfectly at our eye level, which makes sense because if I'm 1,000 feet above the surface, then technically that horizon that I'm looking at is 1,000 feet below me. So obviously it shouldn't be perfectly at my eye level if we use a device. But even, I was just in a plane recently, and it doesn't really matter. As high as you go, when you just look straight out, you can't still tell that the horizon has dropped. Perspectively, perceivably, it is perceivably at your approximate eye level. It's come all the way up to your eye level. Now, this is the one again. We don't have to watch this one. I'll just skip through that. This is one that I got from Witsit. So as the observer here in the drone goes up and down, we see the horizon rising with the observer. Now,
yeah, it's really apparent in a camera because it always, you know exactly where it's pointing. And if you keep it level, especially, it's always at the center of the camera. That's why, here's a little trick. I don't know if you know this or not, but to see further and clearer further, you point your camera either low and have your horizon high or low in your camera. The further away from the center, the more angular resolution you're going to have.
Right.
Just a little tip.
Oh, interesting. Thanks. So now to demonstrate this, we're going to have a look at these Navy ship formations. All right. So when we're looking at Navy ships in these formations, they demonstrate that the horizon is rising with the observer. So, what do we notice about these? We can see that that ship that's really close to the horizon is visually higher than the ships in front of the horizon. But, what do we notice about the horizon itself? What can we tell about the observer by looking at the horizon? So the visual height of this horizon above the ships is giving us a bit of an idea of the approximate height of the observer. So we know that the observer is higher than these ships, because if he wasn't higher than the ships, we would see the horizon through the ships. So I would estimate that we could put 2 of these ships on top here and, we probably wouldn't see 2 ships. Now, if you remember, Jeran, when you did that observation you were talking about earlier, and I remember you commenting on how they're trying to say that we would have 6 cruise liners stacked on top of each other.
Mm-hmm.
Right? Well, here we go. This ship is so far below the horizon that what are we going to do? Have 2 of these ships to be able to see them over the horizon? Now, this is where, to me, this gives us an indication that we know that this person who's observing here is well above the ships, not only because we can see the ships below them, but we can see the horizon well above these ships. Right? So this is how many people seem to think that we see the world, but that's not how we see the world. We see the world like this. Okay, so we know that they're actually all different sizes, and this is something that I did, which is actually from a real photo, a real image. Now, we can tell here which ship is at the back. We can tell which ship is at the front. And if you don't know by now, we're just going to quickly go over them. You should know them by now. We have the front one is visually larger and visually lower. The back one one at the back there is obviously visually smaller and visually higher. Now, this is giving us the indications of where these are in relation to us. And we can see that the horizon is well beyond them. And so what are we going to know about the horizon itself? How is that going to tell us approximately where the observer is? Now, I would say that the observer is on a ship in front, and he's either going to be in that location there or maybe the one above, and because he's the ship in front, he's in a slightly lower position, right? He's in a different position, so he could be on that deck there as well. And we can tell that just by the way that where the horizon cuts through these ships, we know that he's clearly not above the ships, because if he was above the ships, then the horizon would be above the ships. So this demonstrates that the horizon is rising with you. So here now, clearly, we can tell that the elevation of this person is probably on the base of one of these ships, down very low. Maybe they're on a smaller boat. You can tell that obviously that the observer is low because we can see where the horizon is, and we're having to look at the horizon through the ships. So we know that the observer is low. Now we can see that the observer's elevation has obviously gone up much higher. We've got a warship, like an aircraft carrier there on the left, and those things are like 150 feet tall.
Oh yeah, they're huge.
Yeah, they're massive. So we know that this observer, I mean, we can see that even though that ship is well in front, we can see the very tip of that is just sort of on the horizon. So we know that this observer is well over 150 feet above the surface. All right, so we can see that the horizon has to be rising with you. Otherwise, the horizon itself, how are we seeing it above these now? The horizon is extending, and as the horizon extends, it appears to rise. All right, so we can tell that the horizon where the observer is because it's visually well higher than the ships. Okay, so when we have a look at this one here, now we've gone obviously much, much higher. We're seeing a heck of a lot of ships. I don't think anyone would want to see that coming towards them. No. So is it obeying perspective? Clearly it is. Right. And it's hard to get where the exact horizon is on this image because it's very blurred out. But I'm saying it'd probably be somewhere around there. Could be further. Okay. And now this also works in the opposite way. We're like here I'm going, sort of doing that example of like, we're climbing from low to high. But we can also imagine that this is going from high to low and everything's coming back down towards us. So we can see how much lower these bottom ships are than the observer. So, and this is where I'm going into later and on a much smaller scale on how this ship, the very bottom ship, if we were at the exact same observer height, but on the other side of that horizon, that bottom ship is probably 1,000 or 2,000 feet below the horizon. Just as when we're looking at it right now, we know that this observer is probably at least 1,000 to 2,000 feet above the horizon. Maybe they're higher, I'm not sure. It's just a complete rough guesstimate. So as we can tell that boat is that far below the observer right now, and the horizon appears to be that much above that ship. When we're on the opposite side of the horizon in the exact same position relative to where we are right now, that ship would be, I estimate, 1,000 to 2,000 feet below the horizon, and we would not see any of the bulk of these ships that are close to us. Now, as we go in, we can still see the horizon there cutting across these ships. So once again, we're going to be able to tell the approximate elevation of the observer by looking through these ships. I would say, let's say these ships are 20 meters tall. They don't look like they're massive, massive ones. So maybe they're only 20 meters tall, and our observer is going to be at approximately, 15 to 20 meters, maybe 25. I'm not sure. Depends on how big these ships are. Okay, once again, it's a bit of a blurry. It was a very small picture, this one. So I've blown it up. Now it's become very pixelated, but we can see the horizon back there, and we can see that the back ship the horizon is cutting just across the top of that sonar. Whatever you'd call that. I'm not sure what that would be called. But yeah, so it's cutting across there. All right. We're looking here now. So I'm gathering everyone should be getting this idea on how we can kind of easily tell the approximate height of an observer just by looking at how far above the objects in the foreground the horizon is. Now we can see that the horizon here is well above this ship, not massively above. Again, let's say this ship is 20 meters tall. Maybe this person is at about 40 meters or so, just an approximate. I don't know exactly, obviously, but we can tell definitely that the observer is higher than these ships. Right. Now we can tell that the observer is lower. The observer is probably where those people are on the front of that ship, but towards the back of the one that's in front of it. And we can see the horizon cutting through the ships, so we know that the person is not above the ships. They are obviously at around that sort of midpoint of where all these ships are. Right, and now we can tell that the observer is up pretty close to wherever these clouds are. And, the lowest cloud decks are normally, 1 to 2,000 feet. So we have an observer probably anywhere from 1 to 4,000 feet above the surface. And we see that within the horizon as well. We see that the horizon has risen with the observer. Okay, this is obviously going to become very redundant, but it needs to just be drummed into people to see this, and that this is how things are working. The horizon does rise with the observer. Okay, so if the horizon didn't rise with the observer, shouldn't it be dropping? Why is it extending? Okay, we know that the Earth's really big, but that's the point, isn't it? Is that because its Earth is so big, and for us, whether it's an infinite plane or whatever it is, it doesn't need to be an infinite plane because we can only still see so far. But clearly, we know that the horizon extends because that's how we get the distance to the horizon on the Earth curve calculators. When you go up to 1,000 feet, we know that the horizon is further away. The horizon has extended. Well, I get that extension of the horizon without moving. I can get a horizon that is 15 miles away from me, or I can get a horizon that is less than or approximately 3 miles away from me, all from a 20-foot observer height. So to get a 15-mile horizon, I would have to be at 150 feet for a geometric horizon. And to get a 3-mile horizon, I'd have to be down to 6 feet. So I can get a swing from the equivalence of being from a 6-foot observer to a 150-foot observer just by the actual horizon itself moving. Okay, so now we're going into objects disappearing beyond the horizon. And here's just a part of what Brian had with the lasers bending, so I'll just play this.
You see here, the U.S. Standard Atmospheric Chart assumes that there is no water vapor, which is unfortunate because water vapor gradients have the biggest effects on RF propagation. It says in a real atmosphere, humidity is more variable than temperature or density. And this is what they have to do for their globe model to work, because light refracts up. And here's absolute proof of that. Lasers bending upwards. That's all we ever see when we step to the side and get a slight orthogonal view. We never see them bending down, which is what would have to happen on a globe for us to see them in the first place. But we always see them bending up. There's several examples. This alone destroys a globe. Please give me one demonstration of a laser bending down.
Okay, so if someone can show us a laser bending down, that'd be fantastic. But everything that we seem to find, the laser are always bending up, which is creating upward refraction. And upward refraction will also create everything in the distance to drop below the horizon. So we go back to this one here. We don't have to read that out again. But the horizon is that point of deviation where the light is bending. Okay, and that point changes all the time. It can be further away from you, it can be closer to you, and anywhere in between. Right? So how does this actually look? So when we have the horizon closer to us, obviously whichever object there is on the horizon is going to be in the highest visual position. Everything in front of you is going to be dropping lower in your vision, and then everything beyond the horizon is going to drop below the horizon. Okay, this is all just visual though. So then as we move, and now the horizon has moved to be slightly further away from us, the one that was on the horizon now drops below the horizon, closer to us, but still obeying that whole idea. Now the one that was further away is now on the horizon, and the others appear to rise as well within our vision. Now as we move, the horizon moves further away from us, we will get this same effect.
Just want to point out real quick that Bob D says this is actually an incredible idea. So I'm hoping people are paying attention and not thinking this is just repeating something. This is actually something novel, something new and explanatory. Thanks, Scott.
Yeah, thanks for that. So we see each time the horizon moves, let's just say that each one of these are 1 mile apart. And we have a 3-mile horizon here. We have a 4-mile horizon here, 5-mile horizon, 6-mile horizon, 7-mile horizon. Each time the horizon moves further away from us, it's going to change the way that we see everything in front of it. So everything that is in front of the horizon will appear below the horizon. Everything on the horizon will appear in the highest possible visual position, and everything beyond the horizon will do exactly the same thing as what the things in front of the horizon are doing, and it will now start to drop below our vision. Okay, and so obviously this works in reverse. And now, all right, so now we, everyone, if you want to grab a drink or something, this will be a time to grab a drink. I've got a short little video that I've made of this. It goes for a few minutes, so we'll just have a look at this, and it's a bit of a love story between our 2 globe trolls. So enjoy.
Is there supposed to be audio? I'm just wondering.
Yeah, can you not hear any audio?
No, there's no audio. We didn't know, and somebody just mentioned it in the chat, and I was like, maybe I'm the only one.
Yeah, I thought we just weren't hearing it here. They were hearing it on there.
Can you start it over somehow, and then when you go ahead and unshare your screen, and when you reshare it, there's a little checkbox that says "Share with audio."
So
and even if you hit it, Yeah, no. Even if you would have hit it before, sometimes it shuts it off if you don't use it for a while. It's weird.
I have to click onto this little.
Oh no, I mean stop sharing on Skype. So go down to the bottom of this. Not there. It should be. Oh, go ahead and close that chat. Click
the chat. Sorry.
No. Sorry. The right side where it says chat. No.
Oh.
I don't know what happened there.
On the right side where it says chat.
Yeah, now you'll get, there's the share screen at the bottom. Then stop sharing. Confirm stop sharing.
Sharing. Now share again.
Yes, and now this time when you share, see if there's a little button asking you to share with sound.
It's just these ones.
Well, now we can't see your screen because you stopped sharing. So.
Oh right, okay, yeah. So if I start sharing again, it's not.
It never asks you anything about audio?
Oh.
Let me see.
I'm not sure about
share screen.
Apple.
So, can you see my screen?
different.
I just tried to share, and you see where it says share computer sound? You don't get that when you start sharing? I just hit share screen one time, and then it pops up with this screen, and there's a button right there that says share computer sound.
Oh, yeah.
You don't have that, though.
Bugger. Yeah. It's all done to music, bugger.
If you want, you can send me. Is it a video that you can just send me on Telegram? I'll just play it from here.
Hold on a second. Let me. Okay. Where did I put it?
That
I will have to find it. Do you want me to stop sharing for a second, and then maybe Iru can do a thing?
Yeah, I don't know if Iru's still here. He's Iru. Oh, he's here.
No, yeah, I'm here, but I think it's going to be too distractive to.
Okay, we'll wait
to the topic, but we can wait you and. Fascinating presentation. I really love perspective. It was one of the first things that I approach trying to understand the flat Earth, because at least in my opinion, and I talk about this quite a lot in some interviews or conference. If you enter into Wikipedia and type for evidence of globe Earth, the number one evidence still in Wikipedia, and remember that Wikipedia represents other biographies, it says that because a ship disappeared in the horizon, the bottom part before then the top part. And it's amazing thing that, and of course if you're trying to track who said that or where this come from, it was supposedly by a Greek. And remember that we know the names of all the pantheon of the Greeks. Everyone, Aristoteles, Eratosthenes, Pythagoras, etc., etc., etc. But nobody knows the Greek that supposedly see the boat disappearing in the horizon and start screaming all over the place, the Earth is globe, the Earth is a globe. But that's true, Jeran. I mean, who was the guy who said that at that time, and nobody questioned? Can you imagine if you want to represent this in the theater or in the movie, a guy who started, Eureka, I understand now, the Earth is a globe,
right? And
screaming all over the place.
It's ridiculous because that's the one thing they don't get. Like, I keep having these globers come at me and talking about boats disappearing over the curve, and they're like, you can't bring them back forever. They'll eventually. I'm like, okay, you're not understanding the point that we're making. The point is, if you go out to the beach with your eyes, you will see boats disappear over the so-called horizon. If you pull out a camera or a telescope at that point, you can again see that boat. So therefore, any report in the past about 500 BC, 250 BC, 70 AD, that these guys were able to determine the shape of the Earth because boats went over the curve is false, because it means that boats go over the curve today to our eyes as well, and we realize that they didn't go over any curve. So those guys wouldn't have had that opportunity because they didn't have telescopes, they didn't have cameras, they didn't have zoom lenses. So that means that entire description of how we knew that the Earth was curved is just a flat out lie. Doesn't mean it's wrong, it just means it's a lie. So we always point that out, and they can never get it. They'll never, ever get that point. They just I keep hearing people say like, oh, you can't pull it back with a camera. Once it's finally gone over the curve, you can't bring it back. It's like, yeah, but what you're describing happens so far in the distance that we just see like little pixelated boats disappear into the sky almost, which is exactly what, Flat Earth predicts.
Yeah, and especially, that is the first evidence, and then the list go on and start talking about eclipses and about things like this, like that, blah blah blah, yada yada yada. You say in English, and the last one, it's a reference to the because we have pictures from space of the spherical Earth. But the number one is that, and if you need, if you just trying to understand that supposedly 300 years before Christ, this Greek starts yelling that the Earth is a globe because the boat, and nobody at that time, if you just drop a flat, and a Greek is going to question everything you did. So and so in this case, nobody put at the test what this Greek said until 2015 that the new flat earther started trying to, because no Galileo, Copernicus, nobody, Newton, nobody questioned what this Greek said until we reach the point where modern flat earthers start questioning the Greek.
It's ludicrous.
It's ludicrous, yeah.
And there is no story. I mean, you can tell it's all fabricated history anyway. There's no stories of that. There's no stories of this when it it's just like assumed and then agreed upon, and it's how you would write a story of history, not actual history.
Yeah, because if you just name Greek, it's cool.
Right, it's cool and it's
intelligence. Not Sumerian, not Egyptian. It's a Greek.
So smart.
No doubt.
The highlight of human intellectually. Yeah. And if you talking about the Romans, it's control, and it's like they always have these.
No, the Romans. No, it's an old empire. They lose their empire. The Greeks is still on the top, man.
Yeah, they're not as good as the Greeks. You can't beat the Greeks. Okay, when you're ready, I can. Oh, okay, go ahead.
Yeah, it's loading onto Telegram.
You send it to me.
Okay. Yeah, it's being sent, so it's just loading.
Yeah, I'll bring it up here in a second.
Now, yeah, kind of with the boats over the horizon thing. So here we see one. So what I've actually found is that when we have the horizon that's actually in a very close position to us, the boats do. It's once they start going beyond the horizon, there's no real bringing them back. They're gone. But when we have the horizon when it's really extended and it's much further away from us, so by the time this one was getting to around this position here, also due to haze, I couldn't see it anymore here with my naked eye. But if you actually look here, you guys can see my screen at the moment, can't you?
Mm-hmm. Yeah.
So you can see the black of the hull here still.
Mm-hmm.
Right? And see a little white bit just here. So we're still seeing that entire ship. And then this one here. Right, I've had to move this around a little bit. You can still see the black of the hull just there.
Mm-hmm.
A little white of the ship there. You can still see it moving. And then in this one here, so we're now at 29 miles, and it's getting really hard. It's moving just there. I don't know if you guys will be able to get the resolution there. It's right here still. And it was about 31 miles before, like, I just couldn't see it with the camera. And this is in full digital zoom of the P1000. So this one got to 31 miles, and from 21-foot observer height, then that should have been, 360 feet out.
Any way to kind of get an idea of how far away it would be when you lose it visually with your eyes only?
I reckon this one was probably around, because it was also a little bit compressed. So this one here was probably around sort of 22, maybe around that 24-mile mark.
Right. So significantly before you lose it with the camera.
Yeah. I mean, it was tiny. It would only be because I know where I'm looking. Because I've had plenty of other times that people are like, "Oh, what are you filming?" I'm like, "There's a ship out there." They're like, "Where?" I'm like, "It's right there," but you can't really see it anymore. I only know it's there because I'm looking at it and I've been watching it for the past hour.
Right.
Otherwise you can't see it. How's that going? Has that come through to you yet?
And I mean, it's crazy because if the whole story of the Earth being a ball so early, we knew it, in BC times. But then there is stories, and I know they want to say now Washington Irving lied about Columbus, of course, because they don't like the idea of it was just 500 years ago that we came to the globe Earth idea. But it just doesn't make sense that all these supposed people on the boat with Columbus all thought they would fall off the edge of the Earth. When that's 1492, so you're talking about 1700 years before that, they knew the Earth was a sphere. So, and no thinking person would ever think the Earth was flat. So how the hell are these guys, everybody on the boat, afraid they're going to die when they go with Columbus? Do they think they're going to fall off the edge?
Yeah, how'd they sell that ticket?
they can say anything. I mean, that's the thing about authority. When you're just some numbskull in school or somebody who believes everything on the news, it doesn't matter what they say, you just believe it. You're going to just buy into it. Oh, did your paper come through? I mean, your movie come through yet? Let me see. This might be good. No, it still says sending a file. How big is it?
It's only 160 megabyte.
What the hell's wrong with your computer?
It's crap.
Just come a second.
39%.
39% sent?
Yeah.
All right.
40%.
I can do a quick advertisement for you guys. Become a VIP over at Telegram with me and the crew. It is, you go to wap.com/journalism. You get to hang out with me 4 times a month, what's better than that? Every first and third Saturday, we have a hangout with a member of the community. And then on every other Friday night, we have a crypto class that you're welcome to join, listen to presentations, or ask questions. So check that out, whop.com/journalism. This last Saturday, we had a VIP with the one and only Alex Stein, and Duffy McDufferson joined it. What is his first name again? Will Duffy joined us the second half of that VIP hangout. So we got to ask him some questions and grill him and all that fun stuff. So anyway, we've also had Rose 777, Austin Whitsitt, David Weiss. We've had Melodome. We've had Sov. We've had Conspiracy Music Guru, Mark and Patricia. We've had Karen B. So it's a good time and it's well worth it. And you get to join a cool group and hang out and have fun. There you go.
Speaking of David Weiss,
yes.
The new FE Clock app server is online. You just need to update your FE Clock app in the Apple App Store or Google Play Store to connect to the new server. You can scan the QR code on the screen or click the link, type in that link or whatnot below there.
Beautiful. And let me just give a quick public service announcement as far as that goes. I don't care if you're a globe earther. I don't care if you're a flat earther. I don't care if you think we live on a Twinkie. It doesn't matter. You need to put the human beings around you first. Meaning that if you ever find out that a Globe Earth website or a Glober app is leaking data, okay, so people's personal information is being leaked, do not think that the best thing to do there is to go make a video. It makes you a piece of shit. If you're a human being, think about the 200,000 people whose information might be exposed, and why don't you go to the owner of the app and say, we found this thing, can you please clean it up, fix your holes, we won't announce anything till it's fixed, and then you can go on your channel and you can say, look, we cloned this hole, we found this hole, 200,000 people. That's what you should do as a human being. Never as a human being would you think to yourself, wow, 200,000 people's data is exposed. I'm going to go make a video and call them a bunch of idiots and say how dumb they are.
How many flat earthers do that stuff?
None. It's absolutely insane. And of course, we're talking about MC Toon, who felt like his hate for David is more than his love for 200,000 people, or his looking out for them and saying, hey, I got this information that this app might be leaking data. I'll go tell Dave to shut it down. And then you can make your video and act like you're cool after. No. Instead, he put it out there. Oh, there's a site, there's an app that has 200,000 people's data wide open for you. Go get it. I mean, to just make himself seem like he was cool or something. I don't know. Just that when you lose your humanity, it's time to remove yourself from YouTube, remove yourself from making videos, watching videos. If you can't be a human being, if you can't treat others with respect despite their difference in opinions or beliefs, then you're a garbage human. Anyway, that's all.
Agreed, and he is definitely not on the higher rank of human beings, that's for sure.
Well, he's Christian, so he actually ranks way above most. But.
Yeah, it's funny how you could call yourself a Christian and then behave that way. But then I guess we've got a lot of Christians backing something going on right now.
Yeah, exactly. Right.
So it doesn't really seem to matter, does it?
He really? He claims to be Christian?
McToon?
Yeah.
Yeah.
Wow. Okay. I could have swore I would have thought he would have been an atheist. The way he talks and never mind. We're not going to get on the Bible or any of that, but good Lord. I mean.
You mean how it says love your enemies and all that stuff?
Yeah.
No, actually, you didn't look at the next chapter that said berate them follow them around, call them names, lie about them, and gaslight. Chapter 7, you missed it.
Has Duffy come around to that he's not necessarily the great person that he thinks he is, or does he still think he's awesome?
I haven't asked him about that. I should have asked him yesterday, but I don't know. He's not going to make a comment on that.
He doesn't lie. He's such a great guy. He's a great Glober friend. We're at the 73% now. Sorry, guys. Sorry it's taking so long. I don't know why I can't share. So then that means that no one heard Brian Linky. No one heard the one with National Geographic either.
Yeah, and all the data that was pretty much shared on David's app was the stuff you share with every other user on the app. That's what got leaked.
Yes, and then I think people's passwords were also exposed, but it's a reminder to people to please use a different password for every site. And if you're like, well, that's impossible, you can't do that, you should get a password manager, look around. I mean, most of us have done it, and there hasn't been any issues with it. I probably have 500
some are
sites.
like $5 a month.
Yeah. And if you do that,
they're real good. I know Jeran swears by them. They make a new password for you every time you sign in.
Right.
It's amazing.
And it handles it well. And as long as you don't lose your master password, then you're just fine. But yeah, it's just something you should get used to doing. And it's hard to do if you don't use a password manager. Like, how are you going to have a 16-letter or character password that's different for every site? Kind of a pain in the butt. But when you have a password manager, it does it for you. Somebody said, yeah, I mean, all that stuff is exposed anyway. It's just such not a human thing to do. You know, if I showed up one day and somebody said, Sharon, check this out. I got into Simon Dan's back room of his account, and look at all these Globers, full data is exposed. Their addresses, their home address, their passwords. If you think the very first thing I would do is go to my computer, like, I can't wait to make this video. I'm going to make this video that his app is the worst app in the world, and he's a horrible person, and everybody who ever signed up for it's an idiot. He makes it sound like McToon, I'm talking about, in his video, that these 200,000 people that signed up with David's app are just retarded. They're idiots. How could you ever trust David Weiss with your data? Well, how about AT&T, who's lost, hundreds of millions of people's data? Or who was the big one a couple years ago? Yahoo, 2.5 billion people's data. Google
just lost 2 billion. 2.3 billion people or something. Yeah.
So I guess everybody who ever signed up with them is idiots too, because they put their trust into Google. It's just so stupid. It's a complete removal of your humanity, of understanding that nobody who signs up for an app is an idiot for signing up for an app. It's like, it's just such a stupid thing to say. But when you have this hate for flat earthers, you do think of them as less than human. You think of them as less than you. So you can talk about them like they're a subspecies. And if you go back and watch Toon's video, that's exactly what he does. He's talking about Globers. It's one thing. As soon as he's about to talk about a flat earther, a flat earth believer, anybody who's ever downloaded an app, you're like a dog. So he can call you stupid. He can call you an idiot. It's just ridiculous. It's like the most, I don't know. He can talk to Jesus when he gets up there. I'm sure Jesus will have words for him. Say, that's not what I meant by love your enemy. I didn't mean that. I didn't mean treat them like lesser than human. Oh, you misunderstood what you meant. All right.
Well, but maybe he's a Christian of the Old Testament, which is kill your enemy and
that might be
the
right. Yeah, you don't believe the same thing as me? Die.
Isn't Jesus meant to be coming back with a sword this time?
Yes. Kill all his enemies. They're coming. Give it time.
Sound very Christian to me.
Where did you say? Oh, it still says sending a file. What percentage are you at now?
It's almost there. It's at about 98.
Okay.
Yeah, I love when people make songs like this.
Mm-hmm.
I get a kick out of them.
So anyway, I know somebody that messaged me yesterday and said, what can I do to protect myself? Well, just if you remember what password you used for the app, and if it's used on any other site, I would just go and change it from that site. That's basically all you need to do.
It's come through now. I'm going to have to stop sharing, aren't I?
For me to show it? No, you can keep sharing. I'm just going to move this in front of that screen. I'm just picking up a display capture. So I do see it, yes. Yes, mine's downloading, but a little faster than yours. I got a hacker notification. I mean, everything gets hacked. I mean, just really be careful about what you put out there. If you put a different password every site, then you don't have to worry about passwords getting lost or anything like that. All right, here we go. Let me open this. does it say open with?
Yeah, I was just watching a show the other day, and somebody said that because it was about a gaming company who got hacked and all their information. And one of the head guys was like, nobody cares about that. It's not a big deal. And he's like, what do you mean it's not a big deal? It's a huge deal. Oh, he's like, this has happened to so many major companies in the last 7 years that people don't, in 24 hours, it'll all blow over. And he's like, name me one. And he just starts going down this list of all these big companies that have been hacked and information leaked. Yeah, so it happens.
Bob D says, if McToon shared a data dump, he probably committed a crime. It doesn't, he wouldn't give out the URL for it or anything. He was just pointing out that, yes, there was somebody he knew that could get into the back room, exposing all that data due to a API GET request, which is just a URL that you punch in, and then you're able to get returned information. And some of the returned information was clearly private. But by him pointing that out, anybody who was a hacker, who knew what they were doing, would easily say, oh, really? And go get it. Right. So, I mean, like you or I couldn't, because we don't know how to get requests from APIs, but there are hackers who know how to do that. So Chilling in the chat wants to know if there's any hackers out there that can get his password back because he can't remember any of them. That'd be helpful. Thank you. All right, we ready to watch this?
Yeah.
Here we go.
They can hear it on YouTube, though, on the stream.
Sorry, what happened?
That's okay. Just saying that I can't hear anything, but yeah, they can definitely hear
it.
Oh,
you guys can't hear it? Okay, sorry. I'm just going to leave it that way.
Yeah. No, you're right. I just played it. They can hear it.
No, I did not, Bill. The Saga. That's going to be in the theaters, I think, next Friday. Okay, good. Okay, all right, your screen. Oops. Did you stop sharing? What happened?
I'm not sure.
Oh, your sharing's gone, so can you bring it back? Thank you. It went away. Thomas F.E. Gran says there is no upwards hump of water even on the ball Earth, or this hump should exist in a 360-degree circle around you. You stand in a depression on a ball. What should happen? Ship sailed down from start. Now, the hump of water is between you and another person. So, and that does exist. How could it not? If you're talking about you're between two shores, then the globe Earth idea is that there is a hill of water blocking you from seeing the person on the other side. So if you took those two and said, why can't they see each other, according to the globe, they would say that there is a hump of water between the two of them, obviously higher than their eye line. That's blocking them from seeing each other. So you're not right to say there is no upwards hump of water, even on the ball Earth. Well, it depends on what you're talking about. No, it's going to, on the ball Earth, they're going to describe it as entirely level. The whole thing is level, but it doesn't mean that if you have two people, a level ball Earth would get in the way of their eyes. So that is a hump. It's the definition of it.
Yeah, and it's not technically upwards. It drops off straight away, but it drops off into a circle. Like it's definitely a round ball. So on their model, so there's got to be a hump of water in front there somewhere.
Mm-hmm.
Obviously.
Okay, go ahead.
Can you see my screen now?
Yep, it's on basically the senior. Or no, sorry, this has got the ugly girl again in the books.
All right, and then the next one is that, and we'll just go straight to this one because that was the thing. Okay, so we see here. So we remember this image of these ships here, all right? And technically we know that they are all the same size, right? So when we're seeing them like this, but now someone looking from the other side of the horizon in the exact same position, same observer height, distance from the horizon, this is what they're seeing. They're going to see the opposite. Okay, so wrong way. So when they're looking, they're just seeing things from the opposite. Now the things that are the closest to the horizon will look larger and higher than the things that are further away from the horizon, which will now be even smaller and lower. So it's just the exact opposite of how we see. Everything in front of the horizon is larger. Like, so when it's closer to us, it's larger and lower in our vision. And the closer it gets to the horizon, it becomes smaller and rises within our vision. And on the opposite side, it just does the opposite thing. This is possibly, okay. Bugger. No one's going to be able to hear my thing anyway. That's all right.
Maybe we can. We'll try it.
With this one, I could just send you a Twitter link.
I'm surprised that it doesn't play across, though, because that would be the problem with everybody who has a Mac then all the time. If it never asks you to play the audio, then it must assume that it's always playing it, which is weird.
Yeah, I don't know.
You might have to go into the settings of Skype and change something, is my only guess.
It's not even allowing me to play that video. I'll hold it, and maybe I just need to wait a second.
Okay.
It's playing. Can you hear that?
No.
No.
Go real quick to the, if you look at the upper left of your screen, there's the little, or the Skype box, there's a little 3 lines, and then you can get to your menu. Oh, wait, I see it on a Mac. Where's your Skype screen? Yeah, go up to the 3 lines, then go settings. Where's settings? Oh, maybe it's the 3 lines up there, 3 dots, yeah. Try that, and then go settings, and then go audio video. Let me turn this off in case there's anything you don't want people to see. Go here. So if you go audio video, what are the choices there? Camera, video. Go down where it says audio. Audio, let's say microphone, and then it says automatic noise control. Speakers, that's the problem. You have it on 0. You want to just turn that up a little bit now, see if we can hear it. Let's see. No, I don't have any sound there.
No.
That's all right. There's no sound yet.
Oh, well, that's right.
Should start about now. Can you hear anything?
No.
No.
Did I hear anything?
Where would you go to your speakers like right now if you were going to turn the volume up for your computer, or do you have like I only know PCs. PCs have what's called volume control, where we can control individual applications. Where's sound in there? See where it says sound up below notifications? Up a little bit, like 4 things higher than where your little blue bar is. It says appearance. Where'd Paul go?
I was just adjusting some things on the road.
Yeah. Okay.
Stop that. I was just having a quick look to see if it was on the thing.
No, go where you just were, where you had all those settings. Yeah, over there. There you go. Sound. See if it says. It's weird that there's no. Selected sound output device. Play sounds, effects, alert sound. Play effect when volume is changed. Play interface. Okay, so right there, what do you have it set on? You didn't have it on internal. Wait. Input or output? No, go to output. Is it on output? Go there, and it should go to your internal speakers.
Go to my internal.
I would think.
Output? You guys can still hear me and everything?
We hear you, and then go to output volume and turn that up a little bit. Or is it already up? Okay. Applications may be able to access head pause. You could try it, and we'll see if we see it. If not, I don't know. I don't know Max. So I'm useless, basically. Yeah, no sound.
Can you hear that?
No, but also it could, I don't know. It could be you have to unshare and reshare. Is the sound that important, or can you talk us through it?
It doesn't really matter. I mean, people can just see.
Okay.
It's not really massive.
Okay, go ahead.
This is just, I can just go over. Oh, hold on. Okay. I'm going to put you back onto the other one because this is it's all coming through my laptop now.
Sounds good. I screwed up his whole life now. Nice of me.
Computer's going to take over now.
Oh, any day now.
Yeah. So I'll just sort of go over this. So here we have a ship, right? 9:30 in the morning. We can see how the ship there. Now, this is another thing. When the horizon is closer to you, everything is magnified. And as the horizon moves further away from you, everything tends to compress generally. Not 100% all the time, but things generally tend to compress the further away the horizon moves, and they tend to be more magnified the closer it is. Now, this was over a 3-hour period, and we see this ship. I actually had someone think, like when I posted this, they commented like, oh, why are you trying to say that a ship that you filmed coming in is any big deal? And I'm like, well, this ship was actually sitting out there for 7 days. It wasn't coming in. And so now we see that we can see the entire ship. So that's happened over a 3-hour period from that to that in 3 hours. And now we see that the horizon is slightly behind the ship. Okay. Bit of a bugger that the sound part's gone. It hasn't been working, but we just go with what we can. So how did I end up coming to this realization of what's going on with the horizon in the first place? So I started having, obviously, conversations with Twitter trolls. And I would post this picture, mainly the one on the right, and then also have that one on the left there as well. But I'd say, okay, so any of you, can you tell me why we can't see this jetty? Now, if you're a globe believer, your only real answer is because it's over the curve of the Earth. And then after they would answer that, and I only had one person not answer it, really, everyone would turn around generally and say that, but a couple didn't want to, and I would then show them this one. Now, because some of them weren't really engaging properly, I started using this, which is a classic one that a lot of the trolls use. Some even have it as their profile pictures. So then I would say, okay, so what's going on? Why can't we see the bottom of the ship? Now, obviously, I would get things like stupid flurf. Obviously, it's over the curve of the earth, blah, 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 et cetera, et cetera. And then I would go, okay, cool. So why can't we see, go backwards. Now, why can't we see the jetty? Well, after they've committed to the fact that we can't see the bottom of this ship being because of earth curve, really their only answer is to say that this is earth curve. They don't really have another answer for that. So then when I post the other picture and say, well, what about now? Right? That they don't really have anything, because technically this jetty it's only 8 miles away. And according to the globe, there should only be anywhere between 2 to 4 feet of this thing missing. But yet on any time when the weather is decent and it's not really wavy, or I don't have an inferior mirage, I see the shore. 100% of the time, I see the shore. Okay, and I've now done mirror tests from just slightly next to this area, and I've had the mirror down to the sand, and we'll just go over that in a second. But unfortunately, you're not going to be able to hear it, but that's all right. It doesn't really matter. So this is the area that I film, and it's quite small there. So what I'll do is I will blow it up just to show everyone. This is the area. We had a nice inferior mirage this day. So this is the entire area that I film. Right. So here we have the jetty. Just here is where I did the mirror test from, one of the mirror tests. As we scoot along through here. Here I've done another mirror test. This is 12.6 miles away. On this day, we cannot even see the house here. There's a house right there. That top of that house is at about 20 meters. And then we go through till we get to these houses over here. All right. So that's just the entire area. I thought it might be good just to give everyone just a quick look at what we have there. So here's a nice clear day. All right. So this was, I think, the 27th of July. And here's the location for all of those, if anyone wants to sort of have a little bit more of a nosy. The lat longs are there for you to have a look at. But as we can see, top left, we can see the seaweed in the background. We see the entire shore. We see we've got a much better depth perception here as well. So from the buoy to the the top left one, we're still going from the buoy to the little rock formation or reef, and then you can see the nice gap from the reef to the jetty. The one on the left, we can see all the way down. We can almost see the rocks actually on the ground here. In this one, bottom left is Halleck Cove. That where the arrow is pointing, and we can see that little concrete. It's like a little concrete color because it's like a little concrete area there. That's where we did the mirror test from, right there. That's 12.6 miles away. He had the mirror down to 1 foot. And on the left-hand side, we're seeing where our curfew point is. The house is over at Port Noarlunga, and we've got the Buddha over there. So just a quick little bit on actually being able to see how the horizon itself is moving. I'm going to do I'm organizing another presentation where it'll all be just about how the horizon moves. This one isn't really about that, but just a few little things so we can tell and see here on a daily basis how the horizon actually is moving each day. It's always in a slightly different position. It's virtually never, well, I can't say it's never in the same position. It's just always changing. It's always getting closer to me or further from me. So here we have that little area, which I already did just show you anyway. This is where we did the mirror test from. You'll see the house just there. Well, the house is there. Okay. So then this is... How high is it now? Is that your hips? You can't hear it, but I'm asking him how high this mirror is at the moment. Yep. Now, on this day when we did it, there was a bit of a choppy day, and we had about a 3 foot swell, so he had the mirror at his hips. Okay. We then went back on another day. So this one was the 11th of August. And you can see him there on the sand. And again, you can't hear me asking him. But I'm asking him how high he's got the mirror. He's saying to me that it's on the sand. Yeah. And you will see in a moment. Yeah, nothing just yet. We got a flash originally, and there are many more, but there was a bit of a gap between them.
Yeah, this isn't easy to do.
Right when you very first did it? No, not at all. So,
didn't you try this, Jeran?
Just and there we go. So, some nice mirror flashes there. So that's from. Okay, so because you guys can't hear any of that, I'll just skip through it.
Well, I was hearing that.
I heard
That's
that.
Crazy.
Oh,
yeah.
Were you? Oh, you could hear that.
Mm-hmm.
What the hell?
Yeah, we can hear it.
Okay, well, there you go. Maybe we did something. I don't know.
Maybe I did something. I know all the things.
Computer's taken over.
Oh, that's weird. Okay, I don't know why I put that one in there again. Oh, that's right. All right. This is actually the short video. Just did like sort of little videos of the area. So you can see that they're not just screenshots. They're not just photos. They're actual video. And any single thing that I ever show, if anyone wants to question me on it, I have no problem. Just DM me on Twitter. And if you want to do a live and you think you can debunk anything I'm saying, by all means, let's go for it. I'm happy to do a live with anyone at any time, but it will be live. Okay, so here on this day, which was the day that we did one of the mirror tests, we got this real full-on depth perception. So you saw in the other one, so in that top left one, how that gap between the little reef area and the jetty. Skip through that quickly again now. And now we see on this one the gap between the reef area and the jetty. So we've actually got a 3.5 mile gap there. Oh, sorry, it's 5.5 miles away, and then it is 8 miles. So what's that? Sorry, 2.5 miles. No, what did I think? 3. Anyway, and we've got 2 miles in between the buoy and the reef, and we're getting much better depth perception on that day. Now, here we have the buoy. And the buoy is right on the horizon. Now, I didn't list the date, but this is the 19th of September. I have got it down because I go over this one a few times. So here, we actually don't have any inferior mirage. Now, in about an hour's time, there was a very tiny inferior mirage there. But here we actually have the horizon has come to a point that is 3.6 miles away. And we see how much is actually hidden now, right? And so if we actually look, I think I'll put a ring around it later. But if you look to the right there, you can see a mast sticking up. I do show that a little bit later, so maybe we'll just keep going through. So here's another one. This is a slight inferior mirage on this day, though. So here we have the 19th. If I escape here, shrink that a little bit just so people can see there's no inferior mirage here. Right? I had to fully go right through this because I couldn't believe that there's no inferior mirage because it's quite unusual. And I'm thinking like maybe this was it here because a lot of people don't really know how to look for them. But as I was looking through, can't really see any indicators of an inferior mirage. So this here is actually what you would call technically a clear horizon. Now on this day, go back into here, we have all of this hidden. Right? I do comparisons of this in a moment, so we'll see other comparisons. So we have to work out what's going on, right? Because clearly if on any given day we should see the entire jetty and now we don't and everything is missing, it can't be earth curve. There's no earth curve here that all of a sudden sprung up 20 foot missing of this jetty and about 100 feet missing of where on the very top left hand one, sorry, at the very top right. Okay, we've got at least 100 feet missing there. So those houses are at about 114 feet above sea level. So all of a sudden we've got 100 feet missing. And that clearly is an earth curve, although technically the geometric horizon is meant to be 86 feet. Right? But as we go on, you'll see that the default is not for it to be like this. This is not the default at all. The default is to see like almost to the shore all the time. Unless there's an inferior
that's the
mirage.
part that always got me was, I think that's why they never taught us the Earth curve calculations in school, because at only 10 miles, it's 66 feet. That's insane when you think about it. And that's what really did it for me. As soon as I heard that at just 10 miles, the Earth drops over 60 feet from where you're standing, I was like, there's no way. There is no way whatsoever, because I live right by Lake Michigan. And we go up to the beach all the time, and you can look down the shoreline and see for just about ever almost, it seems. You can always see Chicago, especially from northwest Indiana, but you can see it across the lake on most days.
Yeah, it's one of those things. People they don't tend to believe you when you say, oh, there should be 100 feet missing over there, or there should be 30 feet missing. They're like, well, it's only just over there. It's not even that far. What do you mean there's that much? Most people, and that's why people tend to think when we say 8 inches per mile squared, they don't think of the squared. They just think, 8 inches per mile. Yeah, so there should only be 5 feet missing from over there. It's like, no, there should be like 70 feet missing from there, not 4 or 5. Most people are actually quite shocked.
Yeah, that's what I lead with. If I know that, if I can tell they have some kind of, not so much a technical background, but, know math a little bit, I just tell them, go pick out any Earth curve calculator you like on the internet and just type in 10 miles. And it's supposed to drop 60 feet. I always ask them, how much do you think it would drop over 10 miles according to the Earth curve? And they always say maybe a foot, maybe 2. Stuff like that. It's never over 10 feet that they guess. And when they hear 60, their jaw just drops every time. Like they don't believe me. And I tell them, don't believe me. Go look this up yourself. Because I didn't believe it either at first.
No, I don't think anyone really ever thinks about it. Okay, so here now we have this boat here, and then it just moves. And we see that the buoy on this day is, this is still the 19th of September, so the buoy is right on the horizon, or is on the horizon, and it's gone past the horizon now, so now it's starting to drop below. But we saw before that we could see all the way to the shore where that little house there is that house there. And we can see the shore there. And this happens all the time. Like, I reckon if we were to say when there's no inferior mirage, I would say that I can see this kind of scene in a varying degree 70% of the time. Like, this is the default, to be able to see down to this. So we can see where the arrow is pointing. If you go just to the left of that, and you'll see along the horizon there, along the waterline, you'll see like a little sandy colored area. Okay, that I can see all the time. And even that little concrete area, I can see it all the time. Now here, when we look over to the left and we see the buoy, and then we see a sailing boat on the other side of that buoy, we see a completely different scene to this. Right? So we go here on this day, this is 0 feet missing. On this day, we're at about 22, 23 meters missing at 12.5 miles. So clearly we cannot say that this is Earth curve, because even according to the globe and their thing, there should only be about 7 or 8 meters missing. But we're at it more like we're 20, 22 meters here. So this has nothing to do with curvature. So this is why we had to start working out what was going on. We can see the buoy there, and we can see that the horizon is miles beyond the buoy. Right, okay, so sorry, I didn't realize I went into that. So we can see the little structure there. We can see that concreted area, and just to the left there, we see that sandy area. I can see that all the time. Now here, hopefully you can hear this one. This is a friend of mine, Elliot. I actually met him on Dave Weiss's app. We are connected through there. Now, I've got to apologise for him because he reckons when he very first got on the app, he had only just become a flat earther, and he was a little bit trolly in some groups going, tell me this, why is this happening? Why is that happening? And they kicked him out. And he was having a bit of a breakdown.
Yeah, understandable. A lot of us have gone through that.
Yeah. So this was a mirror test, and I'm actually 5 feet. My camera is at 5 feet. You can see that he's at about 2 feet above sea level here. And this is where angular resolution comes in here, big time, because we can see where this arrow is pointing. And there's a 13-meter gap right there. So from where that arrow is to where there's a wall here that's at 13 meters above sea level. This is where we're going to see the mirror flash.
Oh, yep, got another one.
Yeah, we're hearing it.
So wherever you're going to stand. Can you turn away with the camera now? So I've got somewhere to link up our voices, or link up my voice to you doing something. It's so cool, man, because the area where you're coming from, it's in the camera. We're talking. Oh, there's another one. It's kind of orangey too, and that
wow! Look how low that is.
Yeah, it's coming from right in that gap. And so you see where I've got the arrow pointing and the sort of on the right-hand side? That's that little concrete area.
Wow.
That I was pointing at here. That little concrete area right there.
It looks like it's underwater pretty much in that last video.
In this one?
Yeah.
Well, when the shore goes out, so this is getting closer to a high tide right here. Now, when the shore goes right out, this is... Imagine there's no water probably for about 60 or 70 meters. That's how low the tide goes out here. And it's all rocks. It's all these rocks.
That's awesome.
Yeah, and that house, this house just here it must be worth $4 or $5 million. It's crazy. It's an amazing house. The land that it's on is huge, right on the hill overlooking the ocean. UF millions. Yep, skip through that. Okay, so here we have the 18th of September. So the one that we were looking at before was the 19th of September, and now we have the 18th of September. So you can see the swing that we get from day to day. The one that was on the 19th of September, we've had that ship being missing just after the buoy and the horizon on the buoy. We can see that little buoy just on the left-hand side there. And then on the right-hand side, we see we see the house. It's a little compressed now. So we've got a bit of compression going on this day. Here we have the 27th of September. You can see down to that area again as well. If you know that area where the house is, you can still see that little concrete area, the sand area there. All right, so here we have the 19th of September. This is the 28th of July. 13th of July. We're just progressively showing different days, seeing further and further, right, until we're all the way down to the shore level.
Wow.
On the 30th of July. So maybe just go a touch slower so we can see the inferior mirage here and how the inferior mirage hides. And then as the inferior mirage gets lower and lower, I'm going backwards. As the inferior mirage gets lower, to the point where the inferior mirage, I would say, is just ever so tiny in this one. Now it's gone. Now we're seeing all the way to the shore, 100%. We were already seeing to the shore here as well, but this one sort of, there's no denying it anyway. Now, here is this little rockwood area, little videos that I did of the area. Why isn't that playing? Hey. So we can see the difference in the way that this rock wall looks from day to day. skip here. All right, so now this is where I circled that little the mast there. So I would say that there's actually a sailing boat behind there. Again, on the 19th of September, that's that same picture from earlier. And then, so here, I know this one is a bit blurry, so I apologize. But if we look to the very right-hand side, you'll see that there's a catamaran there. All right? So I go backwards on. This was on the 19th of September, and I forgot to put the date of this one, so I apologize for that. But here now we see that catamaran. Now, if we were to put the horizon or the water level in the same position, or first of all, we'll just change that and make it a little bit more visible. So we see a catamaran just there, and then we put the horizon in the same position as where it was a moment ago, and that's what we're looking at. Okay, so now all of a sudden, that catamaran is, 20 feet missing.
Wow.
Yeah. Now, if someone was on the other side, so we go here, that's me looking from this side. Now, if someone had the exact same conditions and they were on the other side of the horizon, then that's what they would be looking at. They would see this boat in this sort of position in relation to the horizon. Okay, so here we have the 29th September. We have this one is a slight inferior mirage, but we can see over to the right there where the house that this is Halleck Cove again, and we can't see that house there. So on the 29th of September, we have this guy out there kite surfing. We see how we have the buoy again on the horizon. We can't see any of the jetty at all, so we're missing about 20 to 25 feet. And from the opposite side, in the exact same position, that's what they would be seeing. They wouldn't see this person, right? They would just be seeing, but from the opposite direction, they would just be seeing the buoy and the horizon. They would not see that person at all. They would probably be seeing his kite. They wouldn't be seeing him because, as we can see, he is below the horizon. All right? So we go back to this ship here, this boat, or this sailing boat here, and if we add a water line in there, that's what they would be looking at from the other side of this horizon, and that's being equal as far as the conditions, because I've actually had it where I'm looking down towards the jetty, the Brighton jetty, and it's an inferior mirage hiding 30 feet of the jetty, and then turned my camera, so that's 8 miles away. And then I've turned my camera 120 degrees, focused onto a ship, pointing onto a ship that is 13.3 miles away, and there's only about 10 foot of that ship missing with no inferior mirage. So the conditions can be 100% different looking from one side to the other. Now it's not normally like that. Normally if I've got an inferior mirage that side, there's normally an inferior mirage the other side. But just as an example of how it can be completely different. I do have a video of that on Twitter. I probably should have at least chucked a couple of screenshots of that in here. But so all being equal with the same conditions, someone on the same side of the horizon or on the opposite side of the horizon, same distance, same height, that's what they would be seeing. So this one here I showed earlier as well. And if we do the same thing and we go to the other side of the horizon, the same position, same conditions, that's what they would see. They wouldn't see that little boat at all. They would only be seeing the sail. Okay, so here we have this. I probably could have done this one earlier. So here we have two catamarans that just happen to be in that same spot on different days. We can see that it's a very similar amount hidden on these 2 days. But we have a catamaran on the other side of the horizon for me, and we have this one on my side of the horizon. And then that's what they both look like if we chuck them together. And if we were to just add some water there and pretend like that it's now moved over, or that's what the other person would be seeing. So if they were on the other side of the horizon, they wouldn't be able to see that whole catamaran. They would be seeing it as I am seeing the one that's on the opposite side of the horizon for me. And then when we look here, we're already seeing a mast just to the left, just to the right there. There actually is a couple of other sails there as well. We see the buoy right on the horizon. And so this happens when we get this horizon has come closer to me. And when the horizon comes closer to you, it hides everything. Now, obviously, we do have an inferior mirage on this day.
Now, would you say this happens more on when the weather's choppy like this, when the water's choppy?
It tends to be more when it is choppier. Yeah, so you do lose more when it's choppier.
Okay. Yeah, I've noticed a lot of these. The water was just. I see a lot of little white caps and stuff like that.
Yeah, well, that's the thing, because when the water is dead flat, well, I see all the way across.
Mm-hmm.
So it's a hell of a coincidence that when the water is at its flattest, we see the furthest. So here, if we add the water in on this one, that's what they would be seeing from the other side. Almost the same as how I'm seeing that, the mast just to the right there. And if we were to add excuse me for a second. If we were to add an inferior mirage for them on the other side, they probably would see exactly what I'm seeing.
Yeah, that's neat how you see the inferior mirage, but you also pick up the buoy in front of it.
Yeah, it's like right on it. And so most of the time when the inferior mirage is happening, the furthest point, it can come in front of the buoy sometimes, not as often, but that's a pretty heavy inferior mirage, and so sometimes it does. So that's why I'd say the closest that I've seen the horizon is probably maybe just under 3 miles to 3 miles away. And again, that's a guesstimate from having hundreds of observations of the same area. But it is a guess. But I know that I know that buoy's 3.6 miles away because I've had trolls give me crap about it. So I literally went and found it and had my camera pointing straight at it, and then I GPS'd myself. And then I worked out how far from the Grange Jetty I was.
And that stuff's locked in your head forever. From Michigan City Lighthouse, Sears Towers, 38.8 miles away, and from 10 feet off the water, 816 feet should be blocked by curvature. Yeah, trolls made me do that too.
Yeah. The trolls are good for you sometimes.
Mm-hmm.
I mean, it's because of the trolls that I came to that I started working this out. So we see here, like this rock wall is 3.6 miles away. So on the left-hand side is closer to me, 3.67 miles away, and on the right-hand side, it's angled, so it's really only about 3.72, I think, 3.73 miles away. And again, just going through with the rock wall, we saw all these before. Now, here I just do some sort of blink tests. So we'll just play them. There's no sound with these. So this is the same day, 2 hours apart. And we see how the horizon has moved. And what we're getting there, so there the horizon's moved. We see that the jetty now becomes in the higher position because it's now closer to being on the horizon. And in the other point, so when it skips over again, which I think it will skip over. Okay, yep. So we now see that the reef was on the horizon. So the reef is now the highest point that we can see. We see the difference in the way the buoy looks. When the horizon has been extended even further, the horizon rising above the buoy. Okay. So here's another one with an inferior mirage. So you can see the inferior mirage is just slightly past the buoy, comparing it to the 30th of July. I think I just started looping these ones because it seemed a bit weird to just continue it over. So we see the difference in the way that it can look from an inferior mirage. Now, again, we have 2 flat days. So because we have the inferior mirage on a flat day, it's not missing as much. So let me just pause it. So we can see that it's not missing as much. We can still see the jetty. But if this was a really choppy day and probably a high tide, we wouldn't see that jetty at all anymore. It would be gone. But because it's flat, we are actually seeing better. Now, I have to throw this in here for Travis from the Plain Truth. So shout out to him. He describes an inferior mirage because it's basically science. What they tell us is that this is a vertical image, that this inferior mirage is just straight up and down. But it's not straight up and down. It's more, I should put his little graphic in here as well. It's more like a shadow of a tree. Now, it's a shadow of a tree that's coming straight towards me, but on the X and Y axis, this is so that inferior mirage is starting at 3.6 miles away, or maybe slightly closer than 3.6 miles to me. So maybe it's 3.4 miles. That jetty is 8 miles away. So that image we're seeing is spread out over 4.5 miles. So it's like a shadow coming towards us. It's not a straight up and down image. So I've definitely seen people, Sean G was questioning about that, didn't believe him. But as we can see here, it's right in line with the buoy. So this is a image coming closer to us. Now here's one from, I think this is on the third. Both of these are on the third. You see the difference in how it looks.
Oh, yeah.
And this is the same day, just 2 hours apart. Let's move on to the next one. So this is comparing to different days. So when Sly says something like, how does an inferior mirage hide this amount of the buildings? This is how. It's right here. When someone says that, it shows you that they haven't gone out and done the observations.
Mm-hmm.
And you know, like, I don't technically blame anyone because, I mean, how many people have actually gone out there and done this much observation? There's a select few of us, you know, and that's not saying that I'm any kind of authority or anything, and I'm not belonging to my own authority, but it's just that people aren't going out and doing this. So,
and you're noticing that what is being said by the mainstream, or what's being described as the science, is just not the case, which is why you're pointing it out.
Yeah, exactly. So now even here, so if we go by again what I just said about Travis from the Plain Truth, well, now this horizon, and I just know that when we get an inferior mirage this big, we've got if they're buoy just on the other side here, the buoy would be like right on the horizon, or maybe this inferior mirages are slightly in front of the buoy, closer to me. So now this is 12.6 miles away. So now we have a 3.6 mile horizon, and then we have 9 miles between here and here. So this image here is being made out over 9 miles. And we know that when the water is flat, we can see all the way across there. This is not being caused because of a curved horizon, because of any curvature. Because when the water is flat, we see all the way across. And I have shown you a few examples of that, and I could show many, many more, but obviously we've got to end it sooner or later. I can't just keep showing over and over. But I will definitely show more. Now look at the way it drops at the top here, and the way the whole image in this one drops. I always just line up the horizon. So if you've got a P1000, if you put the grids on where the grids are, and it breaks it into 9 sections, I put the bottom grid line on the horizon every time. That's where I put it. I didn't loop this one. So if you look at the way that this drops, you see it all the way up here, and then it drops to here. So this isn't being raised up. Most of the time it's dropping, it's having to compress, because now the horizon's extended. And because the horizon is always at your perceived eye level, I know it's not at our eye level before any globers freak out, right? So I know it's not at our eye level, but it's at our perceived eye level. We know that there is a drop there. Okay, so here we have a comparison on how it looked from there. And this is on 2 days that were a high tide, right on the high tide. So the one on the left was an hour before the full high tide, and then the picture on the right was right on high tide. And If anyone wants to complain because of the distortion that's in the other video, please refer back to the other video that was clear and showed the exact same thing. Right? So when we get this distortion, doesn't mean all of a sudden that we see further. The distortion does not make us see further. That has nothing to do with it. It's just the way the light travels. The light is traveling further, and therefore then we see further. Okay, so, excuse me. So again, comparisons of 2 different days. Comparison of this day.
Wow.
Comparing these, the houses that are at Port Noarlunga.
Yeah, when Brian Mullen said that the only way that it couldn't be done optically, you can't definitively say one way or the other, you know, if the Earth is curving at all. I mean, you can say it's not curving at a certain type of thing, but it had to be a mechanical, you know, something set up and built that went out into water. That was
exactly.
Yeah.
And the horizon is purely optical. It is a refractive effect.
Mm-hmm.
And now over here, we see that little lump right there? You guys can see my mouse, can't you?
Yeah.
There's that little lump right there. So that is Curfew Point. And I probably should have included, I went down there, and it's all blocked off. You're technically not meant to go in there. So I had to go through a fence and then went down to this area and I took a video from there. I probably should have included that, but it's not there, so we'll deal with it. So I'll go backwards. No, some reason they're there. So here's another day. Just comparing 2 different days again. Showing how the horizon, that's where I put the horizon, so that the horizon's in the same spot.
Wow.
I think I was meant to delete that. This one here. Now we've got a bit of compression. So can the inferior mirage hide? Yeah, it certainly can. Just looping 4 days there.
Wow.
And so now all of these are taken with the same focal length, and I wasn't doing that before. I only just started doing this in, I think, the end of June, the start of July this year.
Yeah, because it does make a big difference. That's where you get into your diffraction. That has to do with your focal point, because it's all about the size of your aperture. And the smaller your aperture, the more zoomed in you are, the more diffraction you're going to have along your horizon line, the more interference. So shooting with as wide open of a lens as possible, you're going to be able to gather more information.
Yeah, well, so beforehand I wasn't doing it, and then I was watching a video that the Plain Truth had where he was talking to a PhD in optics, and that guy mentioned to him, "Oh, it's great that you've got all these photos in the same focal length, so we can get a proper comparison." And then I just went, "Oh shit, I should be doing that." So now I've started doing it, which is, it's good for now, but it's unfortunate because otherwise I would have 400 days of probably 460 days of comparisons now.
Yeah. Well, we live and we learn. Now you know.
Okay. Yeah. So we're just going to go over another little section here. And here we have our resident Sphere Earth believers. And, clearly we all know how much they love balls. So they seem to think that we see the world like this. We've got this guy in the middle, and he's a little bit I just called him some random guy, and he's not really on their side. He's not on their side. He's a glober, but he's not on their side completely, as you can see. He's a little bit more with it, and trying to explain to him how they think we see side on, and he's clearly confused. Obviously nobody thinks that, and it's like, yeah, these guys do. All of them do. They all think this is how we see the world. They think we see the world in this side-on orthograph or third-person orthographic view. right? But in reality, we see the world like this. We've been going over this the whole time, right? So this should be completely redundant. So this is how we see the world, that all the objects closer to you will appear larger, and they are visually lower, and as they get into the distance, they get smaller. Now, the objects closer to the horizon are in the visually highest position. And as we get closer to ourselves, everything drops in our vision. All right? So, sorry, I just put this together last night. Now, there's this observation here. This is one where Brian, this is part of his, the guy presented this to Brian, going, well, why is this how we see things? Why is the windmill, the turbine, the wind turbine, the only way that it can be explained is on a globe? And then they give us this orthographic view on, it's a complete straw man, because that's not how we see, right? And that's where Sly does all this kind of thing and says, well, the Buddha on, if you can't see it there, but right next to where he puts the Buddha and he's got a little red line, he's like, well, the Buddha's on the same level as that, but yet the Buddha is 138 meters high, and that's only 33 meters high, et cetera, et cetera. And how does this happen? Okay. Well, clearly we all know that the light's bending. So for starters, that's going to create this dropping, because wherever that light touches, once the light bends the point at where the horizon is, that's now the highest point. So everything that goes beyond that will start to drop and end up becoming onto the horizon and end up being on the horizon. Same as when this was just last night, someone's going on about this. Right? It's like they have no idea what perspective is and how it works. Okay, clearly these things, he's trying to say like, well, this is only 8.2 kilometers away and 210 meters. And then this is 125 up to 137 kilometers away. But what he's failing to even mention is the fact that the horizon line under those mountains is raised as well. So if we were to just take that raising away, you would more than likely see those entire mountains.
Oh, yeah.
Oh, where have I got that there? Okay. So I'm just going over this again, just a quick little refresher, reminder on this is how it works. So when we have this guy doing this and saying, well, why is that dropped? Well, because it's now so far away from the horizon, it's dropping below the horizon. All right. So when we take the example now and we use wind turbines instead, we just get the same thing. If we were to move the horizon closer to us, we would get more of those wind turbines hidden. And we can do this without even having to go anywhere. Now, this is pretty much where we're finishing the presentation, and we should have learnt by now how things work. So we see these two observations done by BMLS 69, and Zanuck is all confused, going, well, why is the one below in the left image, the one at the back below the horizon, and then the one in the back on the other one has raised? How has it raised? Why has it raised? Well, let me see. I did. Okay, good. So from here, if we go to these examples again, we see that when something is on the horizon, so if we go to the very left-hand side, the very right-hand side, and we've got the buoy is on the horizon, and then as we go into the middle one, now that little rock area is on the horizon, and the buoy's dropping below the horizon, right? So we see the buoy in that middle one, and the horizon is halfway up the buoy. And then we go all the way to the very left-hand side, and now the actual horizon itself is well beyond here. The horizon is probably actually more like 15 miles away here or more. But that, because the jetty is in the sand, that's the furthest part that you can see anyway. So now the jetty is on the horizon, and we see the way the jetty now raises. So from the very right-hand side image, we see the jetty well below the horizon and the buoy on the horizon. And then when we go to the very left-hand image, we see the buoy now below the horizon and the jetty above the horizon. We get the same thing here. All right, so we have that rock wall on the horizon. We can't see anything beyond it. But when we see, when we see beyond the horizon, when we see beyond it and the horizon goes further, now that rock wall drops in our vision because it has to behave the way perspective works. And now that the horizon has moved further away, the horizon becomes the highest point. The rock wall is now no longer on the highest point or furthest point of our vision, which is the horizon. So it now has to drop below the horizon. Same here. We see this boat in the top left. We see the buoy. We can't see we can see the buoy in the very top right on that one there. So we see the buoy here with the horizon well beyond it on the top left. And we see that boat. On the very top right, we now see the buoy is on the horizon. And this is the top right and the bottom one from the same day again, the same ship, or the same boat. And now that it's gone past, we now see that boat drop below the horizon. So what have we learned about the horizon? That when something is on the horizon, it is in the highest position visually that we see. It's not raising up or down. It's now just because the horizon has moved. Anything on the horizon now becomes the highest visual point that we see. And anything before the horizon needs to be dropping below the horizon, and everything beyond the horizon will drop beyond the horizon. And that's why we now see on the left image, we see the back oil rig below the horizon because it is beyond the horizon, and the one in front of it is on the horizon, which is why we see it in the highest position visually. And now that the horizon has moved to whatever that is, 15, 20 miles, whatever it is, now that back one is now on the horizon, so it now becomes the highest visual point that we can see, and the one in front of it now drops below the horizon because it is now before the horizon. So that clears up that. So hopefully that should be pretty clear for everyone. And this is where we sail away, and it's time to land the plane, and we're done.
Very
Sweet.
nice, man.
Very good job. Appreciate that a lot. If anybody enjoyed that and want to support him, tell them where they can support you and all that fun stuff.
Well, I will. I'm just about to start doing a lot of posting on here on YouTube. I'll start. I haven't posted anything to YouTube really, so I'm about to start dropping a whole bunch of stuff on there. But most of mine is all on Twitter or on X, I should say. Stop being so old. So it's most of my stuff's on X, so you can check me out on X. I don't have any way that you can support me. All of this has been done all at my own personal expense, and hundreds to thousands of hours of work. And I've never asked for a cent for any of it, and I don't have any links for anyone to give me money. But it's no big deal. No one has to give me money. That's fine.
He's basically saying if you want to, you can just send it to kofi.com/globebusters.
Yeah. Yes, please do. Please do. But it's cost me thousands of dollars just in fuel. It's probably a bare minimum an hour driving every day.
That's awesome, man.
So
it sounds like it's a passion.
Yeah, it has become a passion, and now it's become FOMO. But the thing that I like the most is catching, things like the Fata Morganas. That's what I enjoy filming the most. I got some really good ones the other day.
Have you played with any of the macros on those cameras? Like
no.
Taking pictures of bugs or flowers, or it'll change your life. You'll see the world in a whole new way. Yeah. It did for me at least. I mean, you can see, I have a picture of an eyeball of a snail. You can see the blue ring around the little black dot on a little snail. Yeah, those cameras are amazing for taking those types of pictures.
You're right. No, I've never done that.
Yeah, give it a shot.
Yeah, I want to see how they go.
Hey,
thanks for having me, guys.
I want to add, and maybe you can expand upon it.
What do you guys do? You Jews get like backdoor access to these chats, or what?
Zach invited me in. Invited me in. Stop it. Can I share my screen?
Yep.
So I got to stop sharing.
Correct.
Yeah.
Yeah. Hold on. Let me.
How's it going, David?
Going all right, man. Good.
Dave, how you going? How's it been? I'm gonna nominate Toon for Humanitarian of the Year after this show.
Yeah, he's the best, isn't he?
He's the best
one. Wait, where's my?
Okay, so I'm no longer sharing.
Can you see the? Yeah, there you go. You see his picture. All right.
Yeah.
So what happened? I'm looking at the. I shouldn't look at the computer. I should look at what I'm looking at. All right. So you can see this picture, right? We have the. Now this is from a drone. This is up in the air, and then I'm going to show you from the ground, and it's way better. All right. So from here to this red line is a little under 2 miles. We'll call it 2 miles. And from that red line to here, to where the arrow is, that's about 25 more miles, right? So you have to remember, as things go into the distance, with perspective, the sides ramp together, the ground ramps up, the sky ramps down, the clouds ramp into the horizon. But people don't talk about what the back to front compression, right? So you have to, the from the bottom of the picture here to the red line, you have to compress that from the red line to where the arrow is going, 10, 15 more times. That same amount of space is in there. Let me show you a better one. So here we are. This pier right there is less than 1/10 of a mile away. And then from the pier to this land over here is 30 miles. So if we have a sailboat here, and as things go into the distance, they get smaller. Now it's reducing to, from the bottom of the picture to the pier, it gets smaller. Now imagine doing that 40 or 50 more times. Now, if the pier that's right behind, you can see my mouse, I think, the pier that's right behind the boat, imagine that boat getting smaller and smaller and smaller, but in your visual field, it's not getting any farther. It's just getting smaller. So in all of the Globers, when they show these big ships disappearing, and the ones that are really disappearing from the bottom up, and you can't zoom them in, you can't, because there's gigantic waves in front of them that are creating a horizon. The horizon is always 6 feet below a 6 foot tall person, except when there's waves. Then it's blocking. And then as things go into the distance, they're not really even going into the distance visually anymore. They're just getting smaller. So from the corner of that pier to the yellow arrow is, I say it's like 30 miles. So that's 300 times farther than from what the red arrow is showing. So things are just going to get smaller and smaller. Is that what they call foreshortening? Is that foreshortening, or is that something else?
That's something else, I think.
Okay, that's something else. Well, I call it back to front compression. And that's why things disappear, beyond the horizon, because they're getting smaller, but they're not the way we see, they're not actually getting farther away in our field of vision. They are getting farther away because they're getting smaller, but they're not moving. Like that great distance from the red arrow, that's a big distance, but that's 98% of the distance, or even more, from there to where the yellow arrow is pointing. That makes sense?
Yeah.
Mm-hmm.
And so things just go beyond the pier. The pier is the horizon. And it just goes beyond and gets smaller and smaller. And that boat, the top of that sailboat beyond that pier would be below the pier. We wouldn't be able to see it. That's all. That's all I got to say about that.
All he's got to say about that. Well, thank you for dropping in, Dave.
Anything else, Dave, you want to talk
about? For those of you freaking out about the app, thanks for mentioning it. Yes, all of your user data that you share with every other app user was shared, along with your password. That was the biggest issue. But we changed everyone's passwords. And as you said, Jeran, if you use your password in other places, you should change it, but you should never do that. We have new servers up. All you got to do is update your app and you're back online, and we're more secure and faster than before. So in the end, it's all good.
Nice.
Indeed. Yeah, that's the way humanity should work. If there's something like that, then we get together and then we make it more secure. Not
So just, I don't know if anyone heard, I told the story. I'll try to keep it very short. I told it on Flat Earth Fridays.
Oh, that's the first time I'd heard that, by the way. I did not heard that story until I heard you say it on Friday.
Yeah. So, I mean, did you mention it here? You want me to mention it, or?
I did not mention it.
Yeah. So this hacker who's in the internet security business, he found the hole and he tried to reach me, but I had recently changed my website from flatearthpodcast.com to flatearthdave.com, and my web guy, he did a command that said anything that says the Flat Earth Podcast, change it to Flat Earth Dave, and that changed my email contacts to info@flatearthdave.com, which doesn't exist. So the hacker tried a couple times to get in touch with me and couldn't. And the hacker scratched his head. He goes, you know what? I worked with another contractor in the internet security business named Michael. He's in the Flat Earth community. Let me give him the information and see if he can reach the app owner. So he gave him the information confidentially to say, hey, can you see if you can find this guy so he can fix this small issue? And Toon did what Toon did, which is literally the lowest scumbaggery of anyone on Earth. I mean, as you said,
exactly.
Simon Dan's, 2 million subscribers or whatever they are, there was an issue, you would probably just tell him, hey, you want to figure this, seal this up. So the guy just, karma is a bitch. And, the guy that did it is now telling everybody in the internet security business, watch out for this Michael guy. He's a double-crossing, backstabbing scumbag.
There you go.
I mean, I'm being nice. I'm trying to.
A snake's going to do what a snake does, isn't it?
Yeah. And by the way, flat earthers will never address boats going over the horizon. They'll never address that. They'll never address bottom-up obfuscation. That's what they say. No matter how many times we address it.
Yeah.
Amazing.
Well, hopefully, after today, we can start.
Well. Your presentation was fantastic, and it makes so much sense, but Globers aren't going to understand it.
Well, what page of the physics book is it on?
Yeah, what page? Yeah.
What academic paper is it in?
Because only if it's taught in school is it the only way it's fact. That's how it's all worked throughout all of time. Is the only way people have ever learned anything is through school. Never figured anything out on their own. All right, let's head out. Dave, anything coming up this week you want to talk about? Any interviews or anything?
No, just some working on some larger interviews, and I got a couple coming out. I did another high school, and there's a great book coming out that came out, this children's book, which is really good. Zach, a little competition. Maybe step up it sounds like you're stepping up your game a little bit, but the market for children's books is going to be massive as the world is waking up, and children need education materials, so it's awesome. So that interview is coming out. Check them out. They're awesome. They literally, took it's basically the story of a father who's a flat earther and had a small kid, and he's telling the kid about flat earth, and the kid has to deal with it at school and how to address it. And it's really good. It mixes, what God's word in the Bible and scientific fact. And it's a real, coming to the truth story that we can all relate to. It's a book that I say is for 2-year-olds to 99-year-olds, but not 100.
Not 100-year-olds.
Not 100, just up to 99. And it's called, the name of the book, it's on the app, by the way. It's called Who Said the Earth is Flat?
Nice.
Yeah, it's awesome. It's really, really good. So that's all I got to say about that.
Okay, how about you, Zach? Anything coming up?
Same old Iron Realm Media, Monday, Wednesday, Friday morning at 5 a.m. Eastern. Expect to see you there, Jeran. What is that, like 2 a.m. your time?
Yeah, I'll be there. No problem.
Yeah. And then, Thursday night, last Thursday, we did a GLOBEBUSTERS tech on RH negatives, and it hasn't been taken down yet.
Wow.
So, yeah, I'm really surprised. Well, we're scratching the surface kind of a little bit. I'm we'll see what happens this week, because it's going to be at least a 2-parter. We're going to get into it this Thursday night as well. And that's 7 p.m. Eastern over on Thursday night here on GLOBEBUSTERS.
Sweet. And for me, I think I've just got a regular week coming up. We've got Reefer Roulette on Wednesday. Tune in for that. And Friday, Jeran Show. I'm trying to think. I'm going to go live one day, either Monday or Tuesday. I got some stuff to discuss, so we'll get over through that. So yeah, become members at the channel, subscribe, all that fun stuff. And I believe that's it. And then we'll go one more time. You have anything to say? Paul?
No, man, apart from thanks for having me on. It's been an honor to chat with all you guys and present this information. Thanks for giving me the ability or the chance to be able to present it. For me, I'll just be out there doing what I do. I'll go out and film, and now that I've done this, I'll start breaking this down and if you think you could YouTube and start getting some stuff out there on YouTube as well.
I was gonna say, if you think you can do it better, we can do it again on my channel. Or if you want to just go through this and cut out the parts where we're talking or looking for things or figuring out volume, and then I'll repost it on my channel that way too.
Yeah, cool, man. Yeah, either way, I'm happy to do this. I'm trying to reach out to as many of the flat earthers that have channels as possible, and anyone who wants to have me on and do a presentation, I'll do a presentation for anyone.
And how they find you?
Out there who think that they can debunk what I've said, by all means.
Well, I know Ruhif messaged me to say he wants to do a thing with you on debatism or something. I don't know if he's talked to you.
Sure, as long as we go over what I've just presented.
Okay. Yeah, reach out to him, talk to him. He's on Telegram. You can find him there. And just check if there's anything else in the chat we need to discuss. Doesn't look like it. I see London Underground there. Rico's Tinfoil Hat Sombrero. Their podcast is up next. Definitely check that out. Lowry in the house. His podcast is up next.
Yeah, those are always fun.
McToon is trans. Who said that? What? Just because somebody looks like a lesbian gym teacher doesn't mean that they are. Just so you know, it's not always the case. McGoon isn't human. And what Lowry said. All right, guys, been fun. I remind you guys, do your own research. When you do, you'll never again believe all the bullshit. Oh, no, that's the wrong show. Jeez, be kind to each other. Don't lie to each other. Open up your mind. There is truth inside. Till next time, this has been GLOBEBUSTERS, guys. We'll see you soon. Peace.
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 And we are.